Hi everyone, welcome to this course where we are going to build an RPG turn-based battle system. So in this course, more specifically, it's going to be divided into two parts. The first part is where we're going to build the RPG battle system that you see. So a UI with menus where you can use items, etc. I'll go over the more specifics in a moment. And then the second part is going to be about making those battle backgrounds that are reminiscent of old school RPGs like Earthbound. So things like motifs in the background that are achieved using shaders. So we're going to learn how shaders work, at least a basic introduction, and then I'll teach you exactly how to use them in Kaplay and how to make one. So let's get started. Let's jump into the content. So the battle system itself, let me present it to you. So we have our stat sheet here, which displays our stat as the player. So we have our health, attack, defense, level, and experience. And then we have the dialogue box, which will contain the dialogue and also what happens during the battle. So for example, let's start simple. If I want to make an attack, I just press the attack button and then the enemy receives an attack. And here you see the messages that basically details what is happening in the battle. This is also reminiscent of old school RPGs like Dragon Quest and etc. The first Dragon Quest. Now here, it's not just a simple battle system like that. I wanted to go the extra mile, and there's an items system that works, that is included. So here I have a bunch of items, and each of them have specific properties. The apple will increase your health. The boomerang is a way to deal more damage. The poison bottle, if thrown to the enemy, will have a certain rate at which the enemy will be poisoned, and they will have recurring damage every turn. The antidote allows you to heal that status effect. So we're going to have ailments or status effect illnesses, etc. The revealing glass allows you to see the enemy's stats. So something that is in a lot of RPGs is that you cannot know, you don't see a health bar or a level or etc. So in order to know how far you are in the battle and if your enemy is close to dying or something like that, you use an item like a revealing glass here in this example. We're also gonna show you how to have like a leg hold trap, which is a status effect item which will reduce the attack of the enemy. So this enemy has his own stats, so his attack and defense. And the way the battle system is going to work is that you take the attack versus the defense. So when I press the attack button, like when I just do a simple attack or use an item, a calculation is going to go where I'm going to take the damage that my item or my attack deals minus the defense. And the result is going to be the actual damage that is going to be received by the enemy. So by using items like the leg hold trap, which will reduce the attack of the enemy, is going to make sure that they do less damage. Or using a strong herb, here in this example, the enemy will have, actually you, the player, will have an increase in your stats, in your attack stats, to be more specific. All right, so let's use all of these items in this battle. So I'm going to use the poison bottle, and here you can see that the officer got an illness through contact with poison, and then it's hurt by poison, and its health is reduced by 2. And then they do their thing, and I received 4 points of damage, and you can see my health is a bit low now. So I'm going to use an apple, and by using the apple, my health increases by 2, and the officer is being hurt by the poison, and their life is being reduced by 2. Now I received a lot of damage, and here I need to probably use the leg hold trap, which will decrease the attack of the officer by 2. And the officer is now hurt by poison, and now because the officer attacked, and I used this item that reduced his attack stat, I only received 2 points of damage, but I'm in a pickle here. I'm gonna probably die because I only have a health of 1. So here, what do I have else? Now, I don't have enough items, etc. to to survive this, unfortunately. But this is a basic battle system that you can use to in your RPG projects, and then having interesting items will also be very interesting here because it's going to reward exploration. So the player will have to go collect items, try to have a good set of items that they can use in battle or use specific items, etc. So you can expand this project further even after the course. Now here in this specific instance, this enemy only has a simple attack, but the battle is going to be more complex than that. So here I'm going to try to flee, and I fled successfully. Now here is just a setup where I'm going to set up three squares. The red squares are your enemies, and you are the white square. So when I collide here, we have another enemy. And here, this enemy has items as well that they can use. And the way we're going to code our battle system is going to make sure that depending on the items the enemy has, it's going to affect its behavior. So if you give them certain items, they will use them under certain situations. So here the spiders appear. Now I'm probably going to just die immediately. So I'm just going to do a basic attack. And then you can see that the spider used a poison bottle. So it used an item. Now I'm dead basically, so we have to restart the game. So if I instead start the battle with this guy, I can start. You can see that the fact that I had a game over screen, my items are gone forever. So if I want to refresh, I need to like basically restart the game from scratch. Now it's an expected behavior because you want when you're playing the game, when you lose your items, so you have to go in the world, collect them, etc. So here, let's use an item. Let's use the poison bottle, and so, the poison bottle was ineffective because it's a probability that is going to be calculated, but I was infected by the poison, so I'm going to use an antidote to be healed from the poison and not have recurring damage. So what I'm going to do is this. So here I use the antidote. I'm going to use this item that I haven't showcased first, is the revealing glass, which will show me the enemy's stats. So health 6, attack 7, and defense 3. So, and then you see the spiders are smart. It's using a leg hold trap to decrease my attacks, and etc. So that's the battle system in a nutshell. And this is what we're going to build. So I'm going to also show you how to do the backgrounds with shader later on. Okay, so now it's time to do the project setup before we actually start coding the battle system. So here, as usual, I'm going to use Vite, which is the bundler that I use. So I'm not going to spend a lot of time explaining what Vite is because you probably know that if you're an intermediate. Of course, if you don't know JavaScript that well, or don't know the basics of Kaplay, I will link 2 videos that you can watch for free to get up to speed with them. So here I'm going to do npm create vite at latest dot. So of course I've opened Visual Studio Code, which is the code editor I'm going to use for this project. I have opened up a folder. I called it battle-rpg. You can do the same for yourself as well. And of course I assume that you have Node install. So if you don't have Node, you need to install it before you can follow this tutorial. However, there is a bundle-less way of using Kaplay, which doesn't require Node.js. So if you want to do that, you can use the script tag, the CDN. And yep, so if you look on YouTube, you'll find on my channel a lot of tutorials where I do just that. So I don't install it. So I don't use Node, sorry. So here I'm going to take the vanilla template with the JavaScript. And now here I'm going to do npm install, and we're going to install Kaplay. But we need a very specific version, so it's not going to be so that this tutorial actually works in the future for you. So the version I'm going to use, it's version 4000 alpha 4. So that I did this preemptively so that when alpha 4000 is out, this tutorial should hopefully still be relevant. I'm going to try to also update it as we go along, but for if you're the one watching this, follow the exact same version, and then after having followed the tutorial, then you can try upgrading to a more recent version depending on the time you watch this. So npm install at 4000.0.0. Alpha.4. So now that we install this, you can go to your package.json and you can see that the library is supposed to be added here. And we're ready to go. So now it's time to really look at our folder structure. So what we're going to do is I'm going to keep the public folder. This is where we're going to place our assets and our shader code. So shaders have a specific programming language called GLSL to write them in, and we're gonna have to create some GLSL files here. I'm gonna teach you the basics of GLSL also so that you can make your own shaders. But remove counter, remove main, remove JavaScript.svg, and remove even style.css. So I should just do this. And now create a folder called source, which is going to contain our source code. And we're also going to have to create a, maybe not now, but a vite.config so that you can import, easily build the project and deploy it somewhere. So for now, let's just do this. So the source folder and the public folder. Inside of the public folder, for now, there is a v.svg. Really, we don't need that, so let's remove it. And here, let's create a folder. A folder called enemies, which is going to contain the enemies sprites. There's 2 only for this project. And we're also going to need the shaders folder. So I'm going to create a folder, call it shaders. It's where we're going to write our shader code later on. For a source folder, though, the structure is going to be a bit different. So we're going to have an entities folder, which is going to be the code for our various entities. We're also going to have a state folder, which is going to be where we're going to write our logic to handle global state, which there is in this project. So when you defeat an enemy, when you use an item, the system should register that, so that when you play again or you have a game over screen, you don't. It's not as if you haven't lost your items, for example. All right. So now here, the other folder we need is a systems folder. So the reason I call it systems is where we're gonna actually write the code for the battle system itself. And I'm going to go over that various concepts like state machines that are going to be very useful for this. And then we have another folder. This folder is going to be, where is it? So here, let's create a new folder, call it UI. This is where we're going to put our UI components, which is just the various boxes and dialogues, etc. We're going to write our logic here. And then there's a couple of other folders, file series that we're going to need. We're going to need the main.js, which is going to be the entry point of our project, a Kaplay context, which is where we're going to set up Kaplay so that we can use it everywhere else in our project, and a constant.js, which is going to be handy for a specific use case I'm going to cover later on. So now if you open up your index.html, you can remove the div here. You even can remove this line where we have the vite.svg, since we don't really need it. And then finally here, instead of having main.js, you need to have source like that. Source main.js. Now it's time to also set up things in terms of code. So let's go to kaplay.ctx.js, which is Kaplay context. It stands for that. So here in this file, I'm going to import Kaplay from Kaplay, which is, if you remember, we just installed Kaplay, and the way you know that is if you look at your package.json, you should have it here in the dependencies property. All right, so now that we have that, I'm going to go to kaplay.ctx, and I'm going to create a constant called k, which is going to hold the instance of Kaplay, and I'm going to construct this instance of Kaplay by calling the Kaplay global function like that, Kaplay, and pass into it an object with a bunch of params that are going to affect a bunch of things. So let's dive into it. But before that, let's export our k so that we can use it elsewhere in our project. So export default k like that is going to do the trick. So it's going to be the only thing we're going to import from this file. That's why we have the default keyword here. And also the reason we do it here is because in JavaScript, when you have a constant, you cannot do export default here. You could have done it if you had a variable, I think. Or no. With a function, you can actually just have your function declared like that. So export default function, etc., the name of the function. But since we have a constant here, you cannot do that. So I'm going to do const, and of course remove the export. However, you can just do a normal export like that, but you're gonna have to use brackets in order to use it. You probably know this, so sorry for wasting your time. So export default k, like that. Now for the params we're gonna use, and by the way, since we're using Kaplay 4000, there's a bunch of new features we're gonna cover here. That if you're coming from my YouTube tutorials, depending on when you're coming from them, you might not be familiar with certain features, so I'm gonna try to explain them as well here, not assume that you already know them. So here, the first prop we're gonna use is the width of our game, which is going to be 1920 by 1080, and then letterbox true, so that our canvas scales regardless of the screen size. Global false, so that we can only use Kaplay functions from calling this k here and not globally. This is important. I think it allows us to have our code be more maintainable. So that's why I like using Kaplay with global false. Now debug, as I said, I'm gonna set it to true. The reason this is true by default, but when you finish a project, I rather explicitly have it here so that when I finish a project, I can set it to false before deploying the project online. Otherwise, your players are going to be able to access the debug mode, which is not something that you want. Now, another property is going to be the debug key. I'm going to specify the debug key as being F1, but actually I'm going to change that. So pick a key that is really handy for you. Let's say I'm going to pick the D key for this project. When I press D, the debug mode is going to be activated. By default, the debug key is F1, but if you're on a Mac or maybe using the Edge browser, using F1 is not going to be useful, because F1, if you, for example, use the Edge browser, it's going to open the Microsoft help page instead of the debug mode. So it's going to open up a new page, and then you have to go back to your page where your game is in order to see the debug mode, which is not handy. Now this is a new feature in Kaplay. Allows us to map our buttons from the config, from the Kaplay initialization, sorry. Here I'm going to specify a bunch of buttons. So buttons are names that you attach to specific buttons. So what I mean by that is that I can create the confirm button and then set up a bunch of keys for that, so that you can have multiple inputs. So that means one button is going to one button can have multiple different inputs. That means you can use your keyboard or your controller, etc. So this is a new feature in Kaplay, and it's very handy because now you don't have to repeat your on key press logic with various keys. You can just set your keys here and have this name being the common way to refer to this input. So here, for this project, we're only going to use our keyboard, but in case you want to maybe make the game available on mobile or using the gamepad, you can specify here a key for the keyboard keys you want to use and pass them in this array. Or you can below also add gamepad and then or mouse and add your specific clicks, etc. So the specific input. So for this project, the confirm button is going to map to the space key. The left key, oops. And then we are going to have a left button, left button. And for that, the keyboard is going to map to the left key here. And then the same thing for the right key. So here we go. So, yep, so keyboard right, like that. And then the up key, same thing, keyboard, and then up. And then the down key, which is going to be our last key, keyboard, and then down. All right, so we have all of our buttons set up. Now, for the assets, maybe it's a good time to actually import them. Let's do this afterwards, okay? So for now, we're gonna only add the assets when you're gonna need. So by assets, I mean the enemies, sprite, etc. And you're gonna find where to find them in the course. So I should either below this video, this portion of the course, or somewhere at the beginning, I should provide links or even the files themselves you can download so that you can have access to the assets. This project is not very asset heavy since we're focusing on the battle system. So there's only 2 sprites and you can replace them with whatever you'd like. It doesn't really matter for this project. And as for the shaders, we're going to code them. So technically they're assets, but we can just write them right here and there. And we're going to actually do that so that you can really understand how shaders work, etc. All right, so we have this. I hope the screen size is big enough for you to follow along. Everything is fine. So we have our context. Now it's time to go to main.js, and in main.js, it's where we're going to set up our scenes. So here for this project, we're going to have only 2 scenes actually. The first scene is going to be, let me just import k from Kaplay context. The first scene we're going to create using the scene function. I'm going to call it playground, which is just going to be the place where we're going to place our player and the 2 enemies so that we can just test the battle system. And then the second scene is going to be the game over scene, and is just going to display game over and then allow the player to restart the game. Well, to restart the game, but we're actually going to remember that they lost and the item they used. So it's not a full restart of the game. So let's use the go function here to go to our first scene, so the playground. So that's it. That's the project. I'm also going to create a game object here to have a black background. I prefer to create a game object for this rather than using the set background property in the Kaplay options here. You have this option because if you use, for example, set background or background like that, it's going to... Actually, you know what? For this project, I think if you just use background, it's going to be fine. But if you use the set background method offered by Kaplay, it's going to color the whole screen of that background color. That means without respecting the aspect ratio of the canvas itself. So maybe I'm going to try to illustrate this now. So I'm going to open up my terminal and do npm run dev to actually start the project. So here we have our canvas. If I press the D key here, you can see the FPS counter. Now what I'm going to do is I'm going to test it out. So I'm going to leave this empty game object for now. I'm going to go to the Kaplay context and I'm going to maybe right after the letterbox set the background to being black. 0, 0, 0 using the RGB values. So 0 up to 255. By selecting 0, 0, 0, you have a black background. So if I go here, you can see it colors everything black, even the bars of that are outside of the canvas. And this is not what we want. So if I remove this, oops. So if I remove this, I go back to main.js and create my game object, which is going to be a rectangle with the width of the size of this canvas and the height of the canvas. And here I can just specify a color, and the color again pass in the 0, 0 to have a black background. So if I do this and look at the result, you can see it's only the canvas portion that is black and not the things that are outside of it. So I press F12 to open my debug mode, DevTools, sorry. You can see that it's only the canvas portion that is now black, which is what we want for this project. All right, so we have this. So let's dive right into the battle system. So to make a battle system, we're going to have to understand a concept called the state machine. And so instead of jumping right into the code immediately, what I'm going to do is I'm going to make a bunch of schematics. So for this, I'm going to go to excalidraw.com. All right, so I'm on Excalidraw, and it's where I'm going to make my diagrams. So in order to visualize how the battle system is going to work, I'm going to first go and write out the various states. So if you not familiar with how a state machine works, it's a way for you to encapsulate logic, specific logic, that needs to happen when a specific state is reached. So I'm going to arbitrarily write here a bunch of states so that I've decided to name. So the battle start state, maybe I should probably actually start drawing the state machine. So a state machine visually looks like this. So it's a circle that you write inside of it. So I'm going to write battle start. And this is going to be our first state. I'm going to copy that over. I'm going to paste it and have enemy appearance as the second state. Now maybe those are too big, so I should have smaller names. So we have this, maybe bigger. There you go. Battle start. Enemy appearance. Whoops. Okay, maybe that looks strange. So you know what? Let's go medium. Let's go medium as well. And let's increase that to a specific size. Okay. I'm just going to copy this, paste, 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 etc. So we have the battle start, the enemy appearance. We're also going to have a player turn state. We're going to have an attack action state. I'm going to explain all those states, why we have them, and those are all arbitrary names I have decided to name them this way. So I have decided to break down how a battle goes in a turn-based battle system into various states that each have their name, and you reach those states during the battles. And depending on which state you are, there are specific actions that you can do. And this, I think, is the best way to make a battle system, because it's going to make your code very clean instead of having to use if statements everywhere. Yep, so in the main draw loop, which is something I did in the Pokemon P5 tutorial when I had I didn't know exactly how to make a battle system. So I did this way, but in hindsight, I have now a better way that I'm going to present in this course. We have one battle start, enemy appearance, player turn, battle start, attack action. So here instead of battle start, let's have a flee action. So there's 3 types of action the player can take. They can either use an item, they can attack, or they can flee. And then it's either their turn or it's the enemy's turn. So we're going to have another state called enemy turn. And we're going to have a fled state. So if the player tries to flee using the flee action and they're successful, they're going to go to the fled state. And then finally, the last 3 other states we need are the victory state and the defeat state. So now that we have all the states we need, it's time to rearrange them depending on the battle. So how it works: we first start the battle with battle start. So this is the first state we enter when we start the battle. Then the enemy appears on the screen. Then we have the turn of the player. Then the player is going to do either one of 3 actions. So either they're going to do an attack, either they do an attack, or they use an item, or they flee. And now if they flee, and if they try to flee by using the flee action, so during the flee action state, and they're successful, they're going to go to the fled state. Otherwise, they're going to go to the enemy turn. And now here, there's the defeat and victory depends on the enemy health. So from the enemy turn, if the enemy's health is now 0, they're going to go to victory, the player. So let's schematize this even more. So here we go from battle start to the enemy appearance. And then from the enemy appearance, we go to the player turn. Now the player turn can decide between 3 actions. So if they use the attack option, either the items option, and the flee action. So if they try to use an item by using the items menu, then we're going to go into this state and display the items and allow the player to use them during that state. So in code, it's going to be more relevant. So for now, just try to understand it this way. So here, if the enemy action, etc., and then for the flee actions more specifically, if it's successful, it's going to be here. So the battle is going to end. If, however, it's not successful, that means it's going to go to the enemy turn state. And the item action, regardless, is going to go to the enemy state, and the attack action also. So there's only one case in which we can exit the battle by one of these options, and it's the flee action. And now here, depending on the health of the player, the enemy, sorry, it's either going to be a defeat. Actually, you know what? The defeat state is not here. The defeat state is going to be in the player turn. So in the player turn, when we reach that state, we do a check to see if the player is still alive. If they're dead, that means that their HP is 0, then we go to the defeat state. Only in that case. And that means the whole battle ends there. And then for the enemy turn, it's the same thing. So if their health is now 0, they're going to go here. They're going to go, so if the enemy health is 0, the battle system will go to victory because it's from the point of view of the player. So it's a victory for the player and the battle ends there. Otherwise, we're going to have an arrow that's going to go back to the player turn. So if I'm just going to, whoops, that's not what I wanted to do. So here we go. Here we go. Here we go. And now we have the enemy turn, which is going to go back here. So this is not really good. So I'm going to push this away, and put that here. So here we go. We go back to the player turn after the enemy turn. And the enemy turn also uses their actions, but instead of having various states for that, we just do the calculation for them in the enemy turn. Now there's one aspect of the battle that I haven't specified here, is that if you have the item action, so if you try to use an item, but while looking at the items menu, you don't want to use an item anymore, then you go back to the player turn. You go back to the player turn, and which allows you to open up decide on the attack option or try to reopen the items action, or etc. However, if you use an item, then it's going to immediately move to the enemy turn. So this is just a nuance here. So that's how we can visualize the battle system in a nutshell. There's more details than that, but in each of those states, we're going to write logic, and it's going to keep our logic organized. So I'm going to try to put this schematic in the course material so that you can look at it and review it as you want. All right, so now, before we can actually work on the battle system, what we're going to actually need to do is to actually make the setup. So in the playground scene, we're going to have our enemies and player code, movement code done so that they can collide together. And once they are collided together, we can more easily, I would say, launch the battle system and then test it out as we go along. So that way, it's going to be more handy than if we were to write the whole code for the battle system and then only test it once it's fully done. So here we go. So let's create in our entities folder two files. One file is going to be for the enemy. So I'm going to go enemy.js. The second file is going to, that's not what I want to do, for the player.js. So let's start with the player code. So for the player, we're going to have a constructor So it's going to be a function that is going to take care of building the player game object. It's going to take a position and a name as params, and it's going to return a game object that is going to be created by using the add function. So here k, we need to import it from Kaplay CTX, or from the Kaplay context. So here we go. And then inside the components we're going to use, it's going to be a simple 64 by 64 pixel rectangle. So oops, 64 by 64. And then it's going to have an anchor, the anchor component of that's going to be from the center. So the sprite, so the rectangle is going to be drawn from the center instead of the top left corner. We're going to add an area component, so we have an automatic hitbox. We're going to have the body component as well, so that we can have collisions. And I'm going to use the positional component and pass in the position that is going to be passed from to the constructor. And finally, we're going to have a tag called player, so that we can refer to it to this game object later on, if we need to. And then here we're gonna have a game object, and this game object, not a game object, an object that is going to hold a bunch of properties. So it's going to hold the name of the player. So because if you remember, in the game itself, we're gonna have a stat sheet that appears at the top left corner, and this is similar to games like Dragon Quest 1, which had that, and it contains the name of the player and then their stats. So here, for the stats, we're going to have to create a state manager for that. For now, I'm just going to create an object right above, below the function declaration. I'm going to call it player stats. And for now, it's just going to be an empty object. So what I'm going to do is I'm going to set the stats custom property here to being player stats. Later on, you're going to see that this doesn't make a lot of sense, but later on, you're going to see why. We need to call first the, we're going to have a global state management solution. We're going to call the specific player stats we need and then pass into this constant and then use that constant here for our stats. And then here is the meat of the player code, is the actual function, a custom function that is going to set the controls, allow our player to move in various directions. In this course, I'm going to do it in a different way that I usually do on my free tutorials, because I learned a better way to go about it. Is, if you remember, when you try to implement top-down movement, like directional movement, you have this issue where if you move diagonally, you move twice as fast as if you moved either on the left or the right direction. I mean the left, the horizontal or the vertical direction. So in order to fix this, the way to implement player controls properly is to use a on update loop. And remember, since we are creating this function, this method within the game object declaration, we can use this to attach an on update listener that is going to run every frame, so 60 frames per second if the game is running at 60 FPS, and it's going to be destroyed if the player is destroyed. So if the game object is destroyed. So this is a better way of using on update for performance reasons. Instead of having a global on update by using K, you can attach it to the specific game object. So this is something you might have not known. So yeah, please use that in your future games. So for now, let's create a direction vector, which it will allow us to keep track in which direction the player is moving. So here, we're going to have a vector2 with initially 0, 0, and then depending on which keys are being pressed, so which buttons are being pressed, we're going to have different values that we're going to set here. So if K is button down, this is if you want to know if a specific button is down, and here the left button. And remember, we set everything in the Kaplay context where we set our buttons here. So left, right, up, down are from there. So if the left button is being down, so being pressed down, what we're going to do is for the direction vector, we're going to add to the x coordinate of that direction vector -1. So -1 here. So just to be quick, here is everything for all the four directions. So for the up and down, we do -1 because remember the y, the more you reduce the value of y, the higher in the canvas, because the Cartesian plane is inversed in game dev in Kaplay. So that's why it's -1 and not 1. And for down, it's a 1 because the higher the y value, the lower you get. So this is something specific to game dev libraries, and this is how they work. And now for the logic, so for the diagonal movement, still we're doing everything within the on update. So if the direction vector, not x, and the direction vector dot y, that means that we're moving in both directions. So if this is 1 and this is 1, that means it's going to be true and true. What we're going to do is going to be this, and we're going to use the default move function in Kaplay, so that we can move our player alongside this vector, so direction vector, which sets the direction, but we can scale the vector. So the way we're going to scale it is by using a constant that we're going to multiply by the speed. So the speed here, I forgot to set it up. Let's have a speed of 400. So when we have a speed of 400, what we're going to do is the following. So ignore this for now. Let's say we only have the 4 directions. That means we move our player according to that vector, and we scale it according to the speed. So this vector only has 1 and zeros, and -1, and yeah, -1 or 0 or 1 in either one of those two coordinates. So this will basically define the direction we're going to, the player is going to. And we scale this, that means simply multiplying by the speed each of the elements of that vector, that means x and y coordinates, so that we move at the desired speed of 400. So if I just test this out, actually we cannot test this out yet. We need to actually call the player. So let's go to main, and in main.js, I'm going to create the player. So right after this line of code, which let's add a little comment specifying that we have a black background. So what we're going to do here is I'm going to create a constant. I'm going to call it player, and then I'm going to call make player, which is going to be imported from our player.js file. Remember, we added an export function. That's why we can export it. And in make player, we're going to specify the position. Let's put the player at the center. So by passing in k.center, it's going to basically give it this position. And for the name, I'm going to call myself Breeze, but you can put your own name or whatever name you want. And then finally, I'm going to call the set controls method we just created. And now we're ready to test this out. So let's look at the browser. We have a square which represents our player. If I move left and right, everything is all right. Let me just set up the console so we can actually see the consoles if we need it. And then if I go up, but now if I move both up and left and right, I move twice as fast than if I just move in each of these directions separately. To fix that issue, this is where the if statement that we wrote in player.js is going to be handy. I'm going to uncomment this. So if direction X and direction Y are true, that means that we're moving in both of those directions. Then I'm going to scale the direction vector by a factor, a constant. This is a property of math, is that if I go here and here, maybe to the left. So if you have a right triangle, the diagonal is going to be always a factor of, wait a minute, like that. So here is the x position. So let me increase that a bit. So imagine this is a right triangle. We have the x, yeah, y, I guess, call it y. And the diagonal is always going to be a factor of, I don't remember actually. Yeah, it's going to be always the square of 2. A factor bigger by a square of 2. So it's going to be bigger than x and y by a factor of square root 2. Yeah. And so that means if we want to have a, actually, is it this? Yeah. Yes, by, yeah. So I wrote a post explaining this more in detail on Substack, on my Substack. I'm going to link it to the course material. So basically, you just need to remember, because this is not a focus of this course to actually implement diagonal movement, but because the diagonal is always a factor of the square 2 bigger than x and y, the horizontal and vertical direction, we can create a constant. Instead of calculating every time what the diagonal should be, we can just have a constant here in constant.js. I'm going to create this constant, diagonal factor by 1 slash the square of 2. If you multiply that, oh, not here. If you do, what's the name already? I forgot. Diagonal factor multiplied by the speed, you're gonna get the correct length. So you're gonna make sure that the vector is going to be the same as the others. So the other direction, so either horizontal or vertical. Like I said, I go into more depth on this topic in the Substack post you can read, and it's not the focus of this course. Let's test it out. So now if I, wait a minute, I move as fast or even faster. So, oh, I forgot one thing. That's, I forgot an early return statement, because if we are moving diagonally, we don't want to run this code where we scale by the speed. Yep, this only should run if we were either moving only to the left, only horizontally, or only vertically. All right, so now it should work. Yep, now we have the correct movement. All right, so now the other step is to go to the enemy code and do the same thing. And then after that, we're ready to start working on the battle system. We're probably going to need to have our state management set up before we do that, though. And then we can focus fully on the battle system. Once the battle system is done, we can add the shaders, and that will be the course. So in the enemy.js, so let's do the enemy, and then we're going to go back with the state management. So in enemy.js, I'm going to follow the exact same pattern. I'm going to import k from Kaplay. I'm going to export this function, this constructor that's going to make the game object, the enemy. It's going to take a position, a name. It's also going to take a sprite. Now, in the enemies folder, I have inserted the sprite officer.png and spider.png. You should find them near the course material at the beginning or something like that. Add them to this folder so that you don't get lost afterwards. So for now, we only need the position, the name, and maybe the stats that we need to pass, and the items that they're going to have. And I'm going to return a game object. I'm going to again use a 64 by 64 rectangle to represent the player. I'm going to have a color that is of 200 by 10 by 100. This is just a value that looked good. It's going to be like a pinkish red. it doesn't really matter. You can select any color you want. I'm going to have the anchor center so that the sprite, the game object is drawn from the center, not necessarily just the sprite. We don't have a sprite right now. I'm going to have the area component to have a hitbox. I'm going to use a body component. Now here you could decide to have it is static so that it will never move when colliding with the player. Because it's an RPG, what the goal is that when the player collides with an enemy, we run the battle system and the player can no longer move in the overworld and the enemy as well. But we aren't going to write the logic for the enemy to move around or anything like that. Here I'm going to have a position, use the positional component and add the position, and then add a tag called enemy. And this is going to be very useful when it comes to collisions, so we can launch the battle system. And then for the object, the custom object is going to be used to define custom properties. We're going to have the name that we're going to just pass in from the params here. Remember, in JavaScript, you don't have to do this. You can just use this as a shorthand. I'm going to pass in the sprite as well. Actually, we don't have a sprite right now, but we need to actually have it. This a sprite param, which will tell which sprite to display during the battle. And then let's have our stats here, our items as well. And then for now, let's just do that. And now I'm not going to create any the enemy itself right now. What I'm going to do, I'm going to go over immediately to the state. So for the state management, I'm going to have two managers, a game state manager and a player state manager. So for the player state manager, so let's first start with the game state manager, which, as the name implies, will manage the state of the whole game. So it's going to be a function called make game state manager. And in that function, we're just going to call it here in this same file. And then we're going to export the result of that. So here I'm going to create a constant. I'm going to call it game state manager. And make game manager, I'm just going to call it from here. And then I'm going to export that as the default. So export default game state manager. So we only have one game state manager. And within it, we're going to create a constant that is going to be our actual state, and is going to hold a first property that is going to define if the player is in battle or not. I'm going to set it to false initially. Whoops, this is not what I wanted to do at all. So false. And then if it's the player turn. Actually, I don't think I use this I don't use this property at all in my project in the end. And then I'm going to have the inventory here, though, because this in the game state manager, it's for like global data. And we're going to have a specific stat manager because I thought it would be better to have the stats handled separately. So the attack, defense, level, etc., and max HP and HP is going to be handled separately by another manager. Because remember, when you play the game, what happens is that in RPG, you have the same stats, and then sometimes you level up and your stats change permanently. Or sometimes in battle, your stat change temporarily because you used an item or something like that. And I thought, and it turns out to be much easier to just have them separate. So instead of having this one single manager that would handle everything. However, to be honest, you could have decided to just go with a single manager for this current iteration of this battle system because it's relatively simple. So the inventory is going to contain our items. For now, I'm going to leave it empty. So the inventory is items of the player. So it's all from the perspective of the player. So maybe it should have been called player state management, state manager. Because if you think but who's playing the game? It's the player. So that's why it's relative to the player. But if you wanted to be more accurate, you would use this, but I don't think it's that big of a deal. So now I'm going to open up a new file. I'm going to have player stats manager. This is different. This is for statistics, and it's an RPG, so I prefer to have them separate. Here, same logic. I'm gonna have a constructor called make player stats manager. It's going to be called once, and the result of that is going to be exported. So player state manager, the constant is going to player stats manager, sorry, is going to be what is going to contain the stats manager, and this is what we're going to export. So player stats manager. So in that function, we're gonna have a const state. By the way, I forgot to do a bunch of things in the game manager. So let's go back here. Yes, we have our state, but we need to return. We haven't returned anything. Sorry for that oversight. So what we're gonna do is we're gonna return an object that is going to contain two methods. The current method, which is going to return the whole state, a read-only copy of the state. So to do something like that, I use the spread operator to spread the content of that object inside of a new object so that it becomes read-only. That means that if we return this object and it is modified elsewhere, it's not going to impact or modify this here. This is something you need to be wary of, because in JavaScript you can modify the fields of an object by just from everywhere. It is passed by reference. So that's why you need to do something like that if you want a read-only copy. So it will get the current state and give you all the data here. And the second one is the set. Oops. The second one is the set method, which allows us to set a specific state variable here by passing in the key and the value. And what we do inside of that setter, I'm just gonna check first if the key is in the state object, and if that's the case, then we're gonna allow the value to be modified. Otherwise, and we're gonna return. Otherwise, we're gonna throw a new error, and we're gonna have an error message. Can only add new state props, existing state props. Can only modify existing state props. Can only modify existing state props. Here we go. So now we're ready. If I go to the player stat manager, it's going to be the same thing. However, we don't need a more general setter. We're just going to have a single specific setter for one thing. So how do we do here? So for the stats, we're going to have an object here. It's going to have set the health as 10 initially. We're going to have a max health property as well, 10. This is useful for when in battle you're using an item that replenish health. You don't want the health to go above the max health of the player. So that's why I have this property here, so I can know what the max health is. I'm going to have an attack value here. It's going to be 5. Defense is going to be 2. The level is going to be 1. The XP, the experience gain, is going to be a 0. And we're going to have an illness property that is going to have a type. Either, for example, poison, fire, burning, etc. But when the player is healthy, it has the type null, and we're gonna have a recurring damage property, which is going to be 0 when the player is healthy. Otherwise, it's going to be a custom value here that the item that gives the affliction is going to determine the illness, basically. Yeah, and for here, we're gonna return an object with the current method. Again, we want a read-only copy of the stats. So again, we achieve this by using the spread operator, which is going to spread the properties here inside of a new object so that we don't modify by accident the original object here. And we're gonna have a set illness setter here because it's the only thing we're gonna need to set up in this project directly. So set illness is going to have a param of type, what type of disease you want to have, and what type, how much recurring damage you want. And then here we can have stat illness dot type, and then set the type, and then stats illness recurring damage, and set the recurring damage here as well. All right, so we have our state here. We can go back to the player.js, and in player.js here in the movement code, we can do the following that we couldn't do before. So when the player collides with the enemy, we want to prevent the player from moving at all until the battle is done. So either they win or they die, and in that case, they will respawn, and it's going to be after a game over screen. So here what I'm going to do is I'm going to have an if statement called game, and then I'm going to call the game state manager, and I'm going to call the current copy of that. So this should automatically import the game state manager from GameStateManager.js using this line. And then if game state manager, so the current state, a copy of the current state, and then we can have access to the specific property immediately here, is in battle. So if the player is in battle, then we return early, and this will prevent this logic from running. That means the player will be no longer able to move. So that's that. So now let's go to main.js, and in main.js, let's create our first enemy. So in main.js, I'm going to call the make enemy constructor, and I'm going to pass into it the following position. So I'm going to use a vector 2. 1000 by 300 was a coordinate that looked good. You can place your enemies however you'd like. I'm going to give it the name of spider because it's going to be the spider sprite that is going to be used. So I'm going to have again, pass as the third param the sprite name. This is important so that we can know what to display during the battle. And then we have the stats we're going to have for now. So the stats, I'm going to put them here. I'm going to actually, just paste them here. So an attack of 5, defense of 3, health of 6, max health of 6, no illness, and experience of 10. So here in this context, EXP of 10 means that when it is defeated, the player gains 10 XP. I'm going to write the systems for that later on. So now I think we have one thing to specify though, the items. So for the items, I'm going to have the following. So after this object, we can pass another an array this time around, which is going to contain our items. And the way I'm going to go about items is the following. So I'm just going to copy and paste and explain one by one. So an object, an item in my battle system has the following properties. Well, it depends on the type. So for a health type item, it's going to have a name and then a target. Now for the target, this isn't going to be necessary in the current iteration of the battle system. That means that since it's only a 1v1, it's taken for granted that a heal item is going to heal the player and not the enemy. So in case you want to expand upon the project and have battles that have 2 enemies that you fight with, or you have a companion with you, or a team, then you should probably have this target property. So we have the name, which is the apple, which is an arbitrary name. The effect, I have a couple of different effects, and depending on the effect, we're going to write logic to make it behave differently. And a value. So here, this apple heals by 2. And then here we have a poison bottle. It targets the enemy. Its effect is illness. It has the type poison. Its value is 2. So if the illness goes through, it will have a recurring damage of 2. And it is successful at a rate of 0.8, which is 80% success rate. You can play with those values later on. Here we have an antidote, and then again, the effect though is cure, and it cures from what? From the type poison. A strong herb targets the self, its effect is to buff, and the target stat is going to be the attack stat. And it's going to increase it by 2. And then the same thing for debug. So for now, this is all arbitrary properties that I've created, But then we're going to have in our battle system logic to handle those cases, so that every item we use during battle is going to have a different effect. And the same type of items will have the same effect. So I could have another item, call it, juice, have a heal effect and a value of 10, let's say, and it would work in our battle system and have the intended effect. All right, so let's look at the result, and we have our enemy. So now if I collide with it, nothing happens. But now what I'm going to do is let's set up the on collide logic. So again, still in our playground scene, we're going to have a player on collide with the enemy. So any game object with the enemy tag is going to enter in this, is going to fire this on collide. So every time a game object which has the tag enemy collides with the player, it's going to run on collide and run the function here. And the function here is going to be our battle system that we're going to call and pass to it the enemy, which we can have here in the params. So that's the next step. We're ready to start working on the battle system. All right, so now it's time to set up the code for the battle system. So we are not fully ready to just start diving and building the battle system independently from all the other parts of the project, because we're gonna be really reliant on the UI. So we need to have our UI components to really test it out, etc. But there's nothing preventing us to just create what we need, at least a basic shape of our system, of our battle system, and then I'll leave a bunch of code empty and then come back to it later on. So let's do that. Okay. So what we're gonna do is to create in the systems folder, a battle system.js file and an effects.js file. So I'm gonna go over why we need this, but for now let's just focus on one thing, the battle system.js file. So the battle system, the way we're gonna go about it is we're gonna export a default function which is going to make our battle system. So it acts as our constructor. And the input, what will take the battle system in input, are three things. Actually two. The player and the enemy. So if you were to, in the future, make this project, the battle system, more complex with many enemies, maybe you would pass either an array of heroes and an array of enemies, and then you would deal with that on your own. So now what we need is a state machine. So as I explained, a state machine is this thing. And in practice, in Kaplay, how you create a state machine is by creating it from within a game object. So this is something I wish you could do in Kaplay without having to create a game object, but unfortunately you can't really do that. So we're stuck with pretty much creating an empty game object using the add function, and in that game object only using the state component. So we have a game object that is not visible, that does nothing except keeping track of our state machine. So to create a state machine in Kaplay, you use the state component and specify your first state, which is going to be the battle start state, and then pass an array of all the possible states you want in your state machine. As I mentioned earlier, a state machine is comprised of a bunch of states that you yourself define. So if you remember, we had the battle start state as our first state, the enemy appearance, when the enemy will appear. We also had the player turn state, We also had the attack action state. We had the items action state. We had the flee action state, and we had the enemy turn state, the fled state when the enemy successfully flees, the victory state, and finally the defeat state. So let's look at all of them. I think I didn't do any mistakes. Yeah, I think we got them all right. And this is our state machine. So what is cool is that now that we have used the state component, there's also one thing we need to do before that. At the top, if you remember, we created our game state manager, and what we need to do is actually make the, if I remember correctly, in main.js, in our on collide, so you have the option. Either you do it outside, I think it would be best. So outside, when the player collides with the enemy, what you would do is simply use your game state manager that you import, and then set the is in battle prop to being true, so that the player will no longer be able to move. If you don't remember where this came from, it came from, I think it was game state manager, and then here you had the is in battle property. All right, so now that we have this, and we can just go back to our battle system and continue working on it and not do this here. Okay, so now that we have our battle system defined, our state machine, we will first, here I'm going to leave a to-do for all of our UI components. So display the UI. But this is not what we're interested at this stage. At this stage, we just want to define what happens in each of those states. So Kaplay has a on state enter callback for each of your states. So you specify this function on the game object that has the state machine. And then you pass as the first param the state you want to listen on. So here it's going to be battle start. And what you do here as the second param is the function that is going to run once when the battle state, so the state machine, enters that state you specified as the first param. So here on state enter, battle start, etc. What I'm going to do here is to simply, I think, activate, so display, this is actually where we display the UI. So not here, here we set it up, so set out all of our UI constructors. So I'm going to leave that UI setup UI constructors, and here I'm going to have another to do, and it's going to be about displaying the UI, and then that's it. And then once we display the UI, you can use another method from the state machine, from the game object that uses the state machine, just to be more specific. You can have also the enter state function method, where you pass in the state you want to go to. So battle state will go after calling the enter state method to the state passed to that method. So here we want to go to enemy appearance. And that's it. Now there's another method here that is only, you have on state enter, but we also have on state update, and you're going to see it coming up shortly. But for now, let's tackle the other states. So battle state, on state enter, this time around the enemy appearance state. By the way, I think it's a bit of a tangent, but if you remember, I imported the sprites here, but we don't have them loaded in our project yet. So let's do it right now so that we don't forget about it. Yeah, so maybe, actually I should have done this very early. So yeah, go to kaplay.ctx, and then right below, before exporting it, we can do k.load sprite, the officer sprite, and then just type in enemies / officer.png, and then k.load sprite. Spider is the name of our sprite, and then here you have enemies / spider.png. Now we should have everything loaded. Let's make sure that it doesn't cause any issues. Okay, we have nothing here in the console, so everything is fine. All right, so now what we're gonna do is to go back to our battle system. So the battle system is here, and okay, so during the enemy appearance state, what we're gonna do is we're gonna wait a second before moving forward and doing something. So the way you wait is to use the k.wait method function in Kaplay. And this method has two forms, if you remember. Just to refresh yourself, it's k.wait. This is the first form, where you pass in the time you want to wait, and then the function that's going to run after waiting. But this is not what we're interested here. We want to wait before we move forward with what comes next, and this is a natural fit for async await. So we're gonna set up this function, this arrow function that is passed as the second param, as a async function, so that we can use await k.wait. And now this is the second form of the wait method, where you just pass the time you want to wait. We wait 1 second, then I'm gonna have a to do here, because we're gonna do this later, is to display a message introducing the enemy. And then I'm going to go to the next state. So battle state, enter the state, and then the next state is finally the player turn. And now we can define what happens when it's the turn of the player. So for the player, we have player turn and on state enter. And then here, what is going to happen is we're gonna have two things. We're gonna not only have a on state enter, but we're also going to have for that same state an on state update. So to understand the difference between the two, it's not that complicated. The first one runs once when the state machine enters that state, while the other runs every frame the state machine is in this state. So this is the nuance you need to understand. So now here again, a bunch of code that is going to be very specific. So what I'm going to do here is just leave it as a to do, and we're going to fill it later on. And now for the on state update, again, this is something specific, so to the menu navigation, let's leave it later on. Okay, so now that we have this, let's go on with the next state. So battle state, on state, enter. And the next state that comes afterwards is, I think, attack action. So if the player, while they were in the player turn, selected to attack, opted to just attack, we enter that state. And in that state, we have again a bunch of things. So let's leave them all empty. And just so you have a clear overview, and then we'll go back. So it's a bit like drawing. You first do the first sketch, and then you add in the details later on. So here for the attack action, we don't actually need the on-state update for it, because we just do the action and then move on to another state. By the way, I'm just going to do this here below the to-do. So after everything is done, we do battle state, and then enter the state enemy turn. All right. Now the next state that comes afterwards is, of course, the enemy turn. So actually, never mind. It's the items action, because remember in our state machine diagram, we had the following. So once we reach the player turn, we can go in four other possible states. We can go to the defeat state, depending on the life points. We can go to the attack state, the items state, or the flee action state. So because of that, here, by the way, we're gonna have to write the code actually it's here, to check if the health is empty. The health is 0 for the player, and then go to another state. So but for now, let's leave it at that. So battle state, on state enter, and then for the item actions, again, I'm just gonna leave it empty for now. And then here we don't go to the enemy turn directly. What will happen is something, so the action menu, so the menu is also going to be a state machine later on, which will handle a bunch of different cases. It's going to be more clear in the future, like later on, when we're going to be more far into the project. All right, so now we have battle state, on state, enter. Actually, you know what? Never mind. We have an on state update for this items action state, and what happens is as soon as the action, the items has been selected, then we go to the other state, to the after having waited for 1 second. So here in the on state enter, we open up the menu for the items, and then we listen on every frame until the player has made a choice. So here, remember, we're using the wait, so we need to have it as an async to use this form. So now what I'm going to do is to just do battle state, and then enter the state. What's the state we want to enter to? The enemy turn. And then finally, we have the flee action state. So battle state, on state, enter, flee action. Here we don't need an on state update, I think, because it's just, you just click on the flee button, if you remember in the game, and then immediately, depending on the probability calculation, you're going to be able to flee or not. So here we just enter that state, and after that, we will simply go to the enemy turn. Is that right? Yep. Yep. So after battle state, so I'm gonna leave it to do. By the way, I should have left it to do here, so I don't forget later on to do something here. Same thing here. I'm gonna have it to do. And that's it. So battle state, and then enter the state called enemy turn. All right, and then finally, well, not finally, there's still a bunch of states. There is the enemy turn, the fled, the victory, and the defeat. So again, we're gonna have for the battle state, enter state, on enter state, sorry, on state enter, sorry. Wait, it's on state enter, yeah, on state enter. Sometimes I get confused. That's why. So on state enter, and this is going to be the enemy turn. So we're gonna define what happens when it's the enemy turn. And then here again, it's a to-do. We're gonna fill this later on. But what is important to know is that after everything is done, we just wait 1 second and then move on to, so we need an async here. And then move on to the next state, which is the battle state, and then enter state back to the player turn. So when you do this like that, so you have the player turn. So player turn is over, enemy turn is over, player turn until, not until, even if the enemy wins, it's in the player turn state that we're gonna make the calculation that will determine if the player is defeated by checking their health. So having this all organized in this way allows you to really have the code very easy to understand. And the two last states after the enemy turn are the three last states, sorry. Okay, so the last three states, as I defined, was the victory state, so enter, on state enter, victory. So in that case, if it's a victory, then everything is cool. And we are actually, I forgot in the scenes section to actually create the game over. Okay, I did create it, so that's fine. So in the battle system, so yeah, in the victory state, what we're gonna do is to simply first call our game state manager. So remember, this should be imported at the top of the file automatically. In the case if your editor doesn't do it, so you have to do it manually. And then we're gonna set is in battle back to being false, so that the player can start moving again in the overworld and go fight someone else. And then we wait. No, and then that's it. That's the end of it. And then we also gonna do a bunch of logic before that, so to do. And that's it. Now for battle state, enters on. It's not enter state. It's on state enter. On state enter. And then if it's a defeat, what happens is we're going to wait a bit. So we need this as an async function. So await, k.wait 1 second, and then we go to the game over scene. And here a bunch of to do, because we need to display some messages that the player is dead, etc. And then finally the battle state on state enter of the fled state when the enemy has successfully the player has successfully fled. And then we're gonna do a bunch of logic, of course, but the important part is we just need to set the game state manager to is invalid to false again. So you know what? Since we're using the game state manager, maybe it's a better idea to just take this that we had here in the onCollide, remove that, remove the import statement for it as well. And then go back to battle system and then put it there at the beginning. So when we enter the battle, we have this like that. So everything is in the same place. Alright, so this is a bunch of groundwork, and we're ready to start working on the UI components we're going to need for the project, for the battle system, and then as we go along. We're going to display the sprites, etc. Let's go to our UI folder and create a bunch of files we're gonna need, because RPGs are usually very UI heavy with stat sheets, dialogues, items, menus, etc. So I think we're gonna have the most number of files in this folder. And so the first menu UI is the action menu, so create a file for that. Then we need the battlefield. So the battlefield is just like the battle screen. So battlefield.js. And then we're gonna need another file for the items menu. Then we're gonna need one for the stat box, which is like the stat sheet. And we're gonna need the text box.js. So let's first work with the text box. I think the text box is the most important. So to implement the text box, we're gonna have the same thing, the same pattern. So you import k, which we want to use globally, then you create your constructor function. So default function make text box. Oops. And then once you do that, we're gonna first create our text box game object by using k and an array of components. So here for the UI, I wanted to really go simple. Black boxes with a white outline, but looks like old school RPGs. So it's just a rectangle with a width of 1400 and a height of 300. And then something that I've not talked about a lot in my tutorials on YouTube is that you have access to a third param when using the rectangle component. This third param is an object that you can pass in the radius. So the radius is going to be 4. So the radius of the corners of each of the corners of the rectangle. I think that's that, yeah. Then we're gonna specify the color of the rectangle to being a black color, so that's why it's like that. Maybe I should collapse this now. All right. And we're going to use the outline component, which allows us to set the thickness of the outline of the rectangle. Let's go with 5, and then we're going to specify a color. So by the way, just a refresher, you can have the color defined with RGB values, so from 0 to 255 for each of the components, red, blue, and green. Or you can use the k.color constructor. That's why you need the new keyword, because this is a class, where you can specify a color with an RGB as well. So you could have here the RGB value is going to be 230, 230, and 230. This is closer to white, but not fully white. This is just a design thing, is that when you're designing you're using white on top of black, it's a good idea for the white and the black to not be fully white or black, just so they appear softer on the screen. By the way, in VS Code, it's the same thing. You see, it's not fully black here, the theme. All right. And then finally the position. So here the position is something hard-coded. This is what looked good. So I take the center, then the x coordinate in the center, and then add in this offset. And then for the y, I do the same thing and add another offset. So the other offset is, if I remember correctly, plus 150. So now we have our little box here. And then it's time to add our custom methods and functions and custom properties. So here, that's why I use a custom object here. And then here I'm going to set first the dialog, not dispassion, the dialog to being null. It's going to contain the content of the dialog. The lines. So the way the box, the system is going to work is it displays a certain amount of lines at any given moment. So why I decided to go with this design is that it's reminiscent from old school RPGs, and it's also going to make the battle, following what happens in the battle, easier to do, because you can see what happened previously by each line. So it's basically you have maximum 4 or 5 lines that are displayed, and then as new lines are added, they're pushed in the lines array, and the first lines that entered the lines array are going to be pushed out. So it's a first in, last out system. If you did computer science, there are data structures that had LIFO, last in, first out. Yeah, so just remembered that from some of my class. So here we're gonna have our first method called a display line. So what does display line do? Well, display line would just, as the name implied, display the line passed into it. The reason it's async is we're gonna use a wait here. So what I want to do is always to wait 1 second before displaying a new line. This will make it easier for the player to know what's going on, although otherwise if everything appears at the same time, it's going to be very confusing what is happening in the battle. So here, display line, we're going to have first this line. So remember, we can use this because we're inside of that object, this method, and this refers to the game object, which has also access to the custom properties. So this lines, and then we're going to push our text, so our line. And then here we do something special. If the line's length is, actually length isn't written this way, length is superior to 6. The reason I went with 6 is what looked good. So on the 6th line that is added to the lines array, we're gonna push out the first line that was in that array initially. So you can do this very easily in JavaScript using the shift method. So this lines.shift. The reason so you can do that, the shift, let's see if it suggests, it doesn't suggest, sorry, anything. So shift, here we go. Removes the first element from an array and returns it. If the array is empty, undefined is returned and the array is not modified. We don't need to actually get the element that is removed from the array, so that's why I do not assign anything to the left of the operation. And that's it. That's the thing. And then we can just go to dialog, and the dialog is actually where we're gonna have the text as a string that we're gonna then display. And we're gonna have a this dot lines, and then we're gonna join them as a single array, with the separator being a /n, which is the character for a new line. So now all the lines in the lines array are going to be displayed as on their own line by using this character. And that's it for this function. And of course, we're gonna, as I remembered, I used async because after displaying the new lines, we just need to wait 1 second before moving forward. That way we don't have to have this copy and paste this code everywhere in our battle system. We can just have this once here, and every time a line is displayed, it's gonna wait 1 second. So it reduces the number of wait 1 second that we can add, that we need to add, and also it's going to make this customizable. We can, for example, if you expand upon the project, have a system where you can have like settings and increase the font, the wait time, etc. So you can modify this with the param in one single place. All right, next up is the activate method and the deactivate method. Those are arbitrary names, by the way. I just decided to call them this way. I'm going to explain what each of them do. So the first activate, what happens is to just bring in the text box with a cool animation. So what it does, it's a tween basically. It's going to slowly pan out, or quickly, sorry, not slowly, pan out from I think the right side of the screen, the text box, so that it goes into the center. And this gives a nice effect. So to achieve something like that, you can use a tween. And if you remember, tween vary values from a target, from an initial value to a final value under a certain duration, using a certain easing function. So the first here I'm going to use is the position. So this pos x is the position of the text box itself. Remember, because we can have access to the game object itself. Then the target, I want the text box to be in the end at position center minus 500 on the x-axis. This is what looked good. I want all this to happen in 0.5 seconds. And I need to specify the function that is going to update the value gradually. So here you have as a param new pos. You can name it however you'd like, but the form is the same. So it takes one param, and then we're gonna do this pos x new pos, and it's going to gradually modify the position following the fourth param, which is an easing function, which you can have the k.easings, and then here just a linear function is going to do the trick. That's it. Yep. And for deactivate, it's basically the same thing, but in reverse. So here we went to the left. Now I'm just going to copy that and go to the right so that the text box is no longer visible. So I just did plus instead of minus. So that's it. And then one thing, the reason I assigned this as a constant is because we want the text box to have a child. So in Kaplay, you can add a child by having your game object and using the add method on it, passing in a actually no. Oh, I think that's it. Yep. So one thing I forgot to explain is that the reason this is null is, and this we had dialog.text, where did this come from, is we're actually going to store the child inside of that property, and so that we can have access to the text component we're going to need here. So this might have sound strange, and I'm sorry. Hope you arrived this far. So yep. So text box add, and it's not just that. We're gonna have to take our text box dialog and then set it. The reason I did this, I think it's an easier way to name your child game object by using properties like that, so you can easily access them. Otherwise, you'll have to do text box dot children and then remember their position, their indexes, which you could do. But I preferred for this project to go with just creating a custom property and storing the child game object. So you still need to create a game object as you would normally, but just you assign the resulting reference to that game object to this property that I just created earlier on. So inside of that, I'm going to use the text component, which is why in the display line function, I had access to it. So if you go display text here, the text property comes from the fact that you use the text component. And that's why it allows you to modify the content of it. So here it's an empty string. And the reason for that is so we can easily modify what comes after. We're going to set the color of our text to be 230 by 230 by 230, which is near white, but not fully white. And we're going to set a position that is relative to the text box, and 50 by 40 was what looked good. So remember, just to refresh your memory, a position that is set in a child game object is relative to the parent game object. All right, we're ready. So let's return the text box itself. And now in our battle system, so if I go back to the battle system file, we can go at the top, the beginning. I think it was there. Let me just remember. Yeah. So here, when we set up the UI constructors, we can easily just create our UI, our text box UI. So I'm going to have a const text box. I'm going to call it text box, and I'm going to import make text box from here. It should import it at the top, and that's basically it. Now to display it, remember we need to display the UI here. So you just do text box dot activate. Now if we look at the result, and I collide, and nothing happens. Okay, that's strange. Did I save? I activated the text box. Oh, that's strange. Oh, actually, I understand why. We actually are not using the battle system in main.js. So we need to go main.js and then call the make battle system, import it, and then pass in the player as the first param, the enemy as the second param. Now, if I go to the preview and enter, I have an error. K is not defined in battle system. Okay. In our battle system, we used K here, but we need to import it. So at the top, I'm going to do import K from Kaplay CTX. And I'm going to go back to the preview. And we have our box appearing here. So everything is working as intended. Just so I can show you the text feature, let's, in battle start, I think it's here. No, in enemy appearance, we have an await, and then we display the message introducing the enemy, so we can actually just remove that and have an await, because remember, text box dot display line is an async method, which waits 1 second after having displayed the text. And the text we're going to display is we're going to use a template string. So by using the dollar bracket sign, you can pass in the enemy dot name. If you remember in the enemy code, we had access to the name. So enemy name appeared. So I remember, let's actually do this. Yeah, I think that's it. Yeah, appears. That was the way I wrote it initially. So we wait 1 second, then we display the line, and by the nature of display line itself, it's going to wait 1 second before we can move on. So if we go here, I cannot read property of null. I guess. What do you mean? Okay, if I go to enemy.js, we have the name here, enemy. Well, okay, why it's null? So I'm gonna go to the battle system again. We have the enemy here, so everything should be fine. Okay, that's strange. Okay, let's debug this properly. So if I enter like that, okay, nothing happened. It wasn't an issue on my end. Probably I either forgot to save properly. Sometimes it does happen. So spider appears, which is the name of the enemy. So now we go to the player turn. So let's add a bunch of, some text maybe. Maybe we'll do that later on. Yep. So there's a bunch of places we're gonna need to use the display line. a method. But for now, I think we need to actually work on the okay, just to show you, I'm gonna use text box here, display line, and then test. Okay, so this isn't async. By the way, there's nothing preventing you from using an async function without having the await keyword in front. What will happen though is that if you call this and you have some code below, it's going to run. It's not going to wait for that async function to finish. Just for your information, since we're just testing, it's not a big deal. So here, first spider appears, now test. So it appears like that. It stacks itself, and then after a while, actually, you know what? Let's copy. Okay, we're going to need. So what I'm going to do is, instead of doing this here, just to show you, I'm going to go here, and I'm going to have here a message. I'm going to do await, and I'm going to have test 1, and then copy this over and over. So 1, 2, 3. So I have 2, 3, 4, 5, and 6. So now let's look at the result. So you can see how it stacks up and then removes the first line. So spider appears, test 1, test 2, test 3, test 4, test 5, and then test 6, and then the first line was removed. So just to show you that it actually works. Okay, so I'm going to remove that code. And I think we're ready to work on the action menu, which is going to be very important for the rest of the battle system. And yep, so let's do that. Let's work on that. And for that, we're going to first look at the design of it, because it's a state machine, and I'm going to do a diagram of all the states that you can enter in the action menu. And then we also have the items menu, which is also a state machine. So really, the takeaway from this course is that state machines are very useful. They make your code clean, easier to understand, to reason about, especially when you have a bunch of, in RPGs, where a bunch of things can happen. All right, so let's go back to Excalibur. Initially, I had this now, which was our battle system. So let's add a message here, or title, yes, battle system state machine. Now, here, usually in a formal state machine, a finite state machine, because there is also another type, you usually specify the conditions that lead to each state. But here I didn't do it because it's a bit more complicated and I cannot just write it here. So yeah. Now let's have a diagram for our other system, the action menu. So it might sound strange to have a state machine that dictates how do I say it? A menu works, but you're gonna see it's very simple state machine. So here we go. I'm going to draw a bunch of circles again, and our first state for this is the disabled state. So initially our action menu is in a disabled state, which means that you cannot do anything. You cannot select options, you can't do any of that. However, we have other states, so we have 3 other states. So let me just put them here. We have the attack state, we have the items state, and we have the flee state. So what do each of them do? It's simple. So it's simple in the sense that it's not as complicated as this. So what we do here is, first we are in the disabled state. So by the way, in computer science, when you're working with finite state machines, you do this symbol to signify that it's the first state. So you would do this here as well, just for your information. Then, so we enter the disabled state initially, then we activate our action menu, let's say. And what we do with that is we're going to go to either the attack, items, or flee. So we have an arrow in our action menu that can go through these three options. So the action menu doesn't actually do the attack. It's not an attack here that is done. It's just the option in the menu that is on that option. So if you remember the action menu, I'm just going to draw it here. It's a box with three options. You have attack, you have items, and you have flee. Oops, not fleet. And initially, when this is created, we create this menu, and then we go from the disabled state to the attack state. That means the arrow, I guess, like that, is going to point toward it. So that's what it means to be in the attack state under the action menu. So I'm just going to write it, action menu state machine. I think I did, yeah. So I have here. Maybe let's put that a bit farther away. So when you are in the attack state, which is the default option, the first option, so by default, you go from the disabled state where you cannot move the arrow, to the attack state. And then from the attack state, you can either go, you can either go to the items. So here I'm just going to modify the position here to the items state, or you can go to the flee state. So this state machine only concerns itself with how the UI is displayed and not the actual underlying actions. So only when you are in a state called, for example, the attack state, and then you press enter, or you press a key, then we're going to do something. We're going to do something which involves closing the attack, deactivating, so disabling the menu, and then going to another state in our battle system, the state machine, which actually does the job of carrying out the action itself. So you have the attack, items, and then flee. So that means from the attack animation, you can go either to the items, or from the items, you can go to the flee state, or from flee, you can go back to the attack. And at any point when the button is pressed, you can go back to the disabled state. But usually, it's not that, I think, you enter the disabled state only when we create the menu initially, and then when we deactivate it. So, yeah. Anyway, actually, the disabled state is only entered when we want to disable the controls of the menu. So let's just keep it at this simple diagram. So from the attack, you can go to the items. From the items, you can go to the flee. And from flee, you can go to the attack. Until you pick one, and then when you picked one, it's going to actually enter the state, but it's not here that we do anything with those. So the reason it's this way is that this action menu state, so let's keep that in a box. You have the state, the current state. The current state. So here, let's say it's the attack state. Let's put this here. Let's put this here. And from our battle system, inside of the player turn logic, we're gonna read that state. In our on update, I'm gonna read that state like that. Maybe it's not it's gonna cause more confusions, I think. So just remember, this is just only to know which state we're in, and from the outside, from the battle system, inside of the player turn state, we can read what was selected by the player. In the on update, I think it was the on update. If I go to the end player turn, here we're gonna be able to read the input if the current state of the action menu when the player has pressed a key. And with that information, we're going to be able to move on to the other, either attack action state, items action state, or flee action state. So hope this was clear. And again, this diagram is going to be available in the course material if you want to read it, if you want to refer to it later on. Okay, so now that we have understood how it works, let's write the code for the action menu. So for the action menu, as always, it always starts with an import statement to k, and then to a constructor that we export. So make action menu. And now what we're going to do here is create our action menu game object. I'm going to assign it to a constant because we're going to add text, child game objects to it, which are going to be like the text. So here again, we have a rectangle 300 by 299, which is what looked good. I think you could get away with just go 300 by 300 with a radius of 4. Then the color of that rectangle is black. Now I think it's kind of ironic. I told you earlier on that to not use fully black, but here I'm using it, and even in the previous thing I used it. So really it's a matter of taste, I guess, in the end. Feel free to not have near black, so maybe like 10, 12 or something like that for each of those RGB values. Do not have a pitch black box. Okay, so now the outline, again, it's the same logic. So we have an outline, we have 5, and then uk.color, and then 200 by 30, 200 by 30, and then 200 by 30. So an outline of 5. And then the position is going to be 100 by 690, which is what looks good. The opacity is going to be 0. And the state machine is going to first have the disabled state, and then we're going to have an attack state, items state, and then flee state. But remember, you also need to include the first state you added here. It needs to be included. So disabled is going to be here as well. All right. And then it's time for our custom properties. So we're going to first have our options as an array. So we're going to store our various options. So the option is going to be child game objects with each of the text for each of those options, attack, items, etc. Then we're going to have an isActive property, which determines if the menu should be displayed, because the thing about the action menu is it's always there during the battle. It's just disabled or not visible, not able to interact with it when it's not your turn. Otherwise, we just show it back. With the items menu, though, it's going to be different. With the items menu, it was easier to just destroy it every time you select a menu, an item, sorry, or you go back and want to go in, because it's not well explained. What I mean is that you go back, so you have the items selected. It opens up the items menu. You change your mind, so you go back. And then you go back in. So let's say you want to you change again your mind. In that case, we destroyed the game object with your items, and then we went back and then we recreated it. The reason we do this is because every time we create the items menu, we get the updated inventory. So your items, basically. And we need to display them properly, because let's say you open up that menu, you use an item, and then next turn you want to reopen that menu, we need to display the correct items that you have left. And it was easier to just destroy that menu and then rebuild it when you need it, rather than keeping it as we were doing it with the action menu. So here we also gonna have an activate method and a deactivate method. Deactivate method. And then, activate, deactivate. We're also going to have an enable controls method. And we're going to have a disable controls method. So as I mentioned, when it's not your turn, we just make the action menu not visible. We're also going to have a set controls, which will determine how you can navigate and change the various states of the action menu. All right, so we have all our methods here, and now it's time to just fill them up. We're going to do that in a moment. For now, I want to go below and add children to that action menu. So in that menu, I'm going to create a cursor property. Now, the thing is, you can create the property you're going to use here and set them as null and then add them. There's really nothing preventing you from just, creating your own property, custom property on the fly like this. So I would say having them explicitly here would be better, but again, even more better would be to prevent this. So to have a method that you call when you want to add a new property, which will make it clear to others working on your code that this is what you want to do. Now here for this project, I don't think it's that necessary, so I'm going to keep it null here just for your information, but you could have very well decided to not have anything. So here, action menu.cursor, we're going to create our cursor UI indicator, which is a game object with just the text and the arrow symbol. I forget the name of this. How do we say this in English? Greater than symbol, I guess. And then here, dot color, 230, 230, 230. Now I realized something very, like there is also no reason to use this constructor. But let's say you want to use in the future a hexadecimal code. You do this from hex, and you would have it here. So I think, you know what, for this project, we don't need to have a constructor. You can just do this like that. Or maybe you cannot because it doesn't accept a component. It only accepts a like this. So let's keep it that way for now because this is different. We're coloring the text from like directly the game object itself. But we're gonna test that out in a moment. Actually, we can test that out now. So I'm gonna go back to the text box, and for this, instead of having this, I'm just gonna remove that and have a k.color. If this works, then everything is good. So open up the browser, and there's no, it doesn't work. You see, the outline is not working properly. However, if I do this again, we have the proper outline. Okay, so let's keep it that way then. Let's go back to the action menu and add our various child game objects. So here it's the arrow, we're gonna move it later on. So let's set a position relative to the parent. 10 by 40 is what looks good. The opacity initially is going to be 0. So this is one thing that's an issue in Kaplay. It might be fixed if you watch this far into the future, is that the opacity isn't dependent on the parent. That means if the parent has full opacity or 0 opacity, it's not going to change the opacity of the child game object. So that means that when you change the opacity of the parent, you need to also change the opacity of all the other objects, the child game objects individually. That's why I needed to add this opacity component, because in the tween that we're going to have later on, I'm going to have to also set them to the same value as the parent. So something that I'm aware that is probably going to get fixed soon. So here I'm going to add another game object. Actually, I'm going to add a bunch of them. I'm going to push to the options menu. For each of them, the action menu.add new game object, which is going to be the option itself. So here the attack option, and then we're going to have the color, which is going to be 200 by 30 by 230 by 230. As I explained, this is near white. A position that is relative to the parent game object, which looked good. The opacity, because we need to modify this manually for each child game object, and the name of our state, which is going to be attack here. We're going to use that property to know in which state we are, because it's more handy than using indexes for in the array. So this logic, we're gonna copy that 3 times because we only have 3 options. So one, and then another one. So 2 times. And then for each of them, we're gonna modify a bunch of values here for the items. It's here. It's going to be probably a bit below. So 80 for the y coordinate. And here it's going to be 120 for the y coordinates. And we're gonna have the flee name here. Items, again, the name is going to change. Items here, and flee here. And finally, we need to return the action menu. So we really are set up to just write the controls, set controls and the various methods. We're going to do this next. Let's dive into our various methods we need to implement. So let's implement the activate method. So for the activate method, we need to first set the isActive property to true. You're going to see that this is useful later on. Then I'm going to use a tween. And as I explained, the tween is to make the menu visible, gradually appear on the screen. So the first value of our tween is the opacity of the parent game object, so the action menu itself. Then we want it to go to from 0, because initially it's 0, to full opacity, so 1. So opacity varies from 0 to 1. Then we want to do that in 0.2 seconds, and then we will have this function that will gradually update the opacity following in an easing function. And the easing function we're going to follow is, again, k.easings.linear, the linear function. All right, so now we have this. We need to actually write the logic to change the opacity. So we take this opacity and pass in the new opacity. And as I explained earlier, we need to do this for all of our child game object as well. Since we have put them all in an array, we can just do this.options opacity, and then equal to new opacity. And we do this a couple of times. So we're going to do this one, and so we're going to do once here and here. So here I'm not using the reference, the name I've selected here. You're going to see that this is going to be in another use case. But for this use case, this is enough. It's going to change the opacity and put it at the same value as the parent game object. And we need to also do this for the cursor. So cursor, and we do .opacity, and then new opacity. All right, so we have everything for the activate function. So the deactivate function, like the name implies, is basically the same thing, instead of but the contrary. So isActive is going to go back to being false. Then we're going to take our tween logic and replicate it here, but the only difference now is that we want to go to 0. And we want this in 0.2 seconds, and it's really the same logic. So now that we have this done, it's time to work on our enable controls. So when we when the action menu is enabled, that means we exit the disable state. So basically, the enable controls, when called, will first look at the state of the action menu. We can do this by using the this state. And remember, you can use this because we are in the game object. The game object, we're defining this function within the game object. That means this refers to the game object itself. That means we have access to also the state property, which is created when you use the state component. Just to refresh your memory in case it's not clear or you have forgotten it, which can happen. So here I'm going to check if the current state is disabled. And if that's the case, that means we need to actually allow the player to go to the attack state, or just to be able to move. And the way you do this is by simply going to the state, the attack state, which is the first state. So this enter state. So that means exiting the disabled states. That's how you enable the controls. You're going to see in a moment how it works in practice. And now for the disable controls, it's the same logic, but in reverse. So if this state is not equal to disable, disabled, what you're gonna do is this dot enter state, and we're gonna enter the disabled state. Now you could say that it doesn't really matter to have this if statements. Regardless of the state, we just want to go to the disabled state, no matter what. And yeah, you'd be all right. So, but if you want to just save a few calculations, you would just check first, and then if it's already in the disabled mode, then why run this? But it's up to you. You can just remove it. I don't think it will have any impact. I will keep it just like that for I guess completeness, but it's not really that useful anyway. So now let's work on the function, the method that is going to implement the controls. This is, I think, the most important part. It's where also we define the state, what we do, what the logic we run in each state. So we do this on state enter for our first real state, I guess. It's the attack state. And the logic we're going to run here is first we move. So every time we enter one of the states of the action menu that isn't disabled, we move the cursor to point toward it. So cursor move to, you can use the move to. By the way, just an aside. We're using Kaplay 4000. And by talking to the people who make Kaplay, which in the Discord server, the Kaplay Discord server, by the way, you should join that server if you want. There are plans to make pause, so accessing the position via the pause getter, I guess. So this dot pause dot x immutable. So that means you cannot modify it in place. You can no longer do this, for example, and set a value. These are the plans for the future. I'm not sure if by the time you're watching this it's going to be implemented or another alternative, but there is also the move to method you can use to modify the position of a game object by passing the x and y coordinates. And what you can do in this case is you would simply pass in, if you don't want to modify the x coordinate, you pass the current, so this cursor dot x, and then the value you want, for example. So you could do this. Now here for our purpose, we're just gonna do this. So 1040, it's going to move the cursor where we want. Yeah. So this is it also can take a vector too, or you just pass in the two values, x and y coordinates. So just an aside, it's not yet the case in the current version we're using, so there is nothing wrong if you just do cursor.pause.y or x, or just like set it up like that, 1040. It will work for now. I think so. All right, so now let's put it back like that. So the cursor has moved, and now we also need to define what happens while we are in this state. So here the on state update is gonna run every frame. Actually, I'm not sure if it's going to run every frame, but maybe it will tell us. Sometimes on state update. Do you have any documentation? Unfortunately, no documentation. Okay. Anyway, it runs, I think, every frame. So while we are in the attack state, what we're gonna do is we're gonna check for a button press. So if is button pressed, and we want to check if the down button is pressed. Remember that we defined our buttons in the Kaplay context here. So here is the down button and up. So the way you navigate the menu of the action menu, you just go up and down until you select until you stop doing that, and then when you press another key, it's going to be the state you decide. But the way we're going to go about this for the action menu is that we just make sure to allow the player to move up and down, but the actual confirm state button press, the confirm button press, is listed on in the battle system, which will go and check what is the current state in the action menu. So this will change the current active state. So either attack, now we're in disable, but the button press confirming is done in the battle system. It might not be very clear right now, but you're gonna see it when we're gonna add the action menu to the battle system. You're gonna see how it works. Okay, so you have here the attack and then the S button pressed. Now if the button pressed is down, we simply can do this. So we're gonna enter the state that is right below, and remember in the menu, the state that comes after the attack state is the item state. So here, if I go back to the diagram, you see the menu, you have attack, items, flee, attack, and then what comes after the attack is items, and then flee. Now this is a bit hard-coded, but you're gonna see in the items menu, we're gonna write logic so that we can have a menu that adapts itself regardless of how many states you have. So the way you're gonna go about the items menu, since we can have many items, and we don't know in advance how many items we will have, it's going to write some logic that will adapt to it. But in this case, in the action menu, we only have like 3 options. Then it makes sense to just hard code them and just get on with it. So now that we have this, we also need to have the on state enter of the items state. And here what we're going to do is simply like here, we're going to move the cursor. So I'm just going to copy and paste that. But where we're going to move it is to 1080 instead. Here we go. And then here again, we need the on state enter items. And then here we're going to have the logic to go up and down. So if k.is button pressed is up, that means we need to go back to this enter state, the attack state, which is above. And then we return early. Now here you don't need to return early since it's the only statement you have here. But here in this case, we actually need to return early because we have another if statement. So if instead the button being pressed is down, then we want to enter this .enter state the flee state, and then we return early. And then here again, you don't have to return early at this stage, so you could decide we don't return early, we return early here, and we don't need to return early here. And even if you want more conciseness, if you even you can just remove even the brackets and have everything in one line like this. So you have this like that, and then like that. Let me just do it this way so that it's very concise. But then again, if you want in the future to add some code in this condition, you'll have to put back the brackets because you can no longer just stay on one line. Okay, so now the last state is on state enter flee, and here we move the cursor to 10 and then 120, I think the value was. I think it's 120, I'm not sure. Yep, yeah, it is. So we move here and then this on state update flee, and here we just need one if statement if the button pressed is up, because we can no longer go down. Now, optionally, you could have decided that when you are in the last item in the menu, you could just, by pressing down, move up again. But in this case, I just preferred to just be like when you arrive here, you can only move up. It's a simpler, and I think it's more intuitive. But depending on your taste, you could decide to implement it this way. So here, you can only go up when you're in the last option, and we can simply this dot enter state, and it's going to go to the state that is right above, which is the items state. That's it. That's all the logic we need for the action menu. So now we're ready to go to our battle system and try to use it. So let's call it. So what we're gonna do is let's create our action menu right below here. So I'm gonna have action, a constant called action menu. I'm gonna call the constructor make action menu. It should import it automatically on top of at the top of your file, the battle system.js file. And then here we need to pass the battle state. Actually, do we need, oh, wait a minute. I don't think we need anything. I think I probably missed something, or no, it's fine, it's fine. We wrote it correctly. So what I'm gonna do now is after you have called the action menu, what you need to do is first set its controls. So set the controls of the action menu once it's created. The reason you do this is because as soon as the battle starts, you should be able to have the controls set up. And then in the battle start, I think maybe after the enemy appear in the player turn, actually, it's where you're going to display the menu. So here, the action menu. So once we reach the player turn, I'm going to do something. If the action menu is active, so is not active, remember this is a custom property we had in our action menu game object. So as long as this is not active, we're going to activate it. So activate the action menu by calling the activate function, a method, which is going to make the action menu visible. And then we're going to call in the action menu enable controls, which will enable our controls and make the action menu state go from disabled to attack. And that's it. That's basically it. There's a bunch of logic we can go later on to confirm, etc. We're going to write that in a moment, but let's check out the result. So if I go here, spider appears and then my menu appears. Now there's something strange here because here the cursor is not in the right position. That's because I probably, if I go back to the action menu, I did not create the cursor as a child of the action menu. So you need to change this. Now if I go back and hit here, spider appears, then I have my menu. And now there is another issue. The issue is that for some reason, I skip immediately from attack to flee and to flee to attack. So that's very strange and we need to fix that. Oh, I know why. The move to something I forgot. It's not like you cannot pass in a vector, the two values as if it were a vector 2, because the move to, if you pass two params, one is the vector and the other is the speed. So you need to do k.vector2 and then pass it like that. So, sorry, that was an oversight on my part. So here you don't need that. I was right about this, I think. So let's remove it. And here also you need to pass in a vector2, because move to is you pass in the direction as the first param, which is the vector, and if optionally you can pass a second param, and the second param is just going to be the speed. And that's why we had an issue, because we don't need to have the speed because we want the cursor to go instantly to the position we want. So now if I go back and then try to navigate the menu, you still have the same issue. All right, so the issue I had, the reason I had the bug is because here in the on-state enter, I had two on-state enters, and you need to have on-state update. So it isn't an issue related to return statements at all. And it isn't, I think so. I'm gonna test in an instant. And it isn't an issue related to, yeah, it's not an issue related to anything else. It's just I made a typo here. I wrote twice on state enter while this should be an on state update. So now if I try it again, I should be able to move properly. Here we go. All right. Ooh, now it works. Okay, so now what we're gonna do is we're gonna go back to the battle system and make the selection. So the logic to select one of these action and do something accordingly. So now, for now, what we're going to do is we're going to go to the onState update of the player turn and write some code. If k.isButton pressed. So if we press the confirm button while we are in the player turn, that means the action menu is opened because of this statement. Then what we're gonna do is and then we can check this current state of the action menu by just having the dot state. And the dot state is a property that is available when you use the state component. So you can, from the outside, check if a specific game object is in a particular state. So here the state we want to check for is if the action menu is in the attack state. That means the player has the cursor placed near the attack menu and they have pressed the confirm button, because otherwise we wouldn't check the action menu state. That means the player pretty much wants to attack. And in that case, we're just going to take our battle state and enter a new state, and that state will be the attack action state. And in that state, we later on gonna write the logic to do the damage calculations, etc. And we can return early because we have another condition to check. So actually, I think we can rewrite this in a way that does not need if with an if. Usually, it's a good coding practice to not do that as much as possible. So here what I'm going to do is if the k is, so if the button pressed, sorry, is not confirmed, then we return early and we do not run what comes afterwards. That's the way we can take for granted that we are doing, we are running, so we can take for granted that when we check for the action menu state, we are pretty much sure that the player has pressed the confirm button. Otherwise, the logic wouldn't have gotten past that point. It would have returned early. So I hope you understand this and how it makes your code easier to read, because now we don't need to have an if within an if. However, just as a caveat, if you need to write logic in that onState update later on, and you actually need to do something even if the confirm button has not been pressed, I would recommend either you do it on the top here, so what comes before, or you simply put back the ifs within if statements. So now the other one is if the action menu state is the items, then we're gonna do two things. So if the items is, okay, so we need to check the inventory of the player. So if they try to access the items and they have no items, basically, we need to display something. Otherwise, we're gonna do something else. So here again, we could either have a second condition. So either have two if statements, one where we have the state, we check for the item's state, and we do some logic, or yeah. So either we have two if statement, one with the extra condition that we need to check. We need to make sure that if the inventory is empty. So the way you would do that is if the action menu items is like that, and game state manager, which is where we hold our inventory, so current, to get the current read-only copy of the inventory, if that and the length, since the inventory is in array, is equal to 0, what we're gonna do is we're gonna have an await, and we're gonna display call the text box display line, and basically return a message, a visible message in the text box that no items left. Oops, sorry. No items left in the inventory or in inventory. And then we can return early. Now here we're using await, so we need to change this to async. The other option you could have is you put this as an if within the if. So your call really. So here in the other case where the inventory is not empty, because if it was empty, it would go through this and return early. We can can go to the enter state, the items action state, which we're gonna use to open up the write logic to open up the menu, the item menu, etc. And of course, we return early. Now, the last one is if the action. So really, since it's the last one, you don't need an if statement, because if all the other cases would have happened, you would just have a return early. So you could just, for the flee, just immediately by default enter the flee state. Now, it depends on how you want to, in the future, maybe add some other options, etc. And you'll have to adapt this code. So that's why, for this reason, I'm just going to add it as an if. So it's explicit and someone else reading your code knows what this last option is. But anyway, they would know because they would see battle enter state flee action. So it's up to you, really. Since I'm not going to add another option anytime soon, I'm just going to not return, but call the battle state, enter state, and then flee action from here. And then we return. The reason I'm calling a return here, actually we don't need that. Wait a minute. I closed the, whoops. So if I go back to battle system, okay, everything should be fine. All right, let's test this out and see what happens. So here we go here, and we have spider appears, and then I can choose, and then if I click, for now nothing happens. We actually no items left in the inventory. Okay, so we know it at least works. Okay, so now let's write the logic for all the other what happens next. So basically, let's first start with the attack action, and then we're gonna go with the items action, and then the flee action, and then yep. So let's write the logic for what happens when the player selects in the action menu to attack. So first of all, we need to deactivate the action menu by using the deactivate method. Whoops. By the way, one thing I forgot to mention is that the reason I'm using deactivate and activate without an async await is that if you go in the action menu, I did not use for these tweens the async version, the await version, because we don't need to await what comes next. We don't need this at all. So it's going to disappear while the other logic runs, and it doesn't matter in that case. So we have our action menu, we deactivate, and then we await, and then I'm going to display the line. Basically here, I'm going to write that the player.name to access its name, or their name, had decided to attack. Attacks. So remember, add an async here. If you don't, you're not going to be able to attack. Now, we're also going to have a wait here. There's a thing here. We're going to add an effect later on. So I'm going to write a to-do and say make enemy shake, like they got damage. And then here I'm going to, again, do the to-do for the effect for that. So the damage calculation. So to-do damage calc, and that's it. So here we go. Finally, let's go to the items action, and for the action we are going to need two things. We're going to need to disable the controls of the action menu. The reason we do this is when you select the items option of the action menu, it opens up the items menu. And while we are in the items menu, we shouldn't be able to interact with the action menu, but we don't want the action menu to be deactivated, because we still want the action menu to be visible and still there, because at any point the player can decide to stop their action where they wanted to use an item and go back to the action menu. It's only when they have selected the item and then press confirm, then that way we're going to deactivate the action menu and we're going to destroy the inventory, the items menu. So both the action menu and the items menu in that case. So here we don't have the logic for the items menu yet, so I'm gonna do a to do activate items menu here. And then finally we have the items action. Here again, this is something that is contingent on having the items menu logic done, so that might be the next part of the tutorial, of the course. So flee action is something that I think we can really implement very easily. So we're gonna first create a constant. I'm gonna call it can flee, which will determine whenever or not the fleeing attempt of the player is going to be successful. And the way I've decided to go about this is I'm gonna do a Boolean check, and whenever or not this Boolean check is true, it's going to determine if the player can flee. But also, in the case where this Boolean check fail, we can have a random occurrence at 0.5, so a 50% chance of succeeding. So the way I'm going to go about this is I check the enemy stats health. I check their health. By the way, I don't remember if I added this. So if we go to the enemy code, we have their stats, and if we go to main.js, they make enemy, we have their stats, so we can use that. So in battle system, if the enemy stats health, so if their health is inferior to the enemy stats max health, divided by 3, then the fleeing is automatically successful. That means the enemy is too weak, So the player should be able to, not enemy, player here. The player should be able. Oh, never mind. Yeah, we first check whether or not the enemy's max health divided by 3. So we're checking basically whenever or not the enemy's health, whenever or not the enemy is sufficiently damaged, because if their current health is inferior to the third of their max health, that means they're really in a bad situation, and that means they're too weak to do anything if the player tries to flee. Otherwise, we're gonna have a random. So in random number between 0 and 1, you can achieve this in Kaplay by using the rand function. You can use this, you can achieve this in vanilla JavaScript by having a math.random, etc. But since Kaplay offers a function for it, why not use it? So rand 0, 1, okay. If the resulting number that is picked is inferior to 0.5, that means there's a 50% chance of this occurring. And that means if it is, it's going to be true, and that means the fleeing is going to be can flee is going to be true, and we're going to allow the player to flee. So in that case, so here I'm going to just below the calculation await, but well, it makes more sense that this happens first before we determine whether or not the player can flee. So we're gonna have a line, so text boxed display line, and if the message we're gonna have is simply the player.name fled attempted to flee. So let's use a template string for that. Let's also add this as an async function. So we're gonna have here, so $ brackets player.name attempted to flee, and then that's it. And then we do the calculation whether or not I'm going to allow them to flee. And then if can flee is true, we can achieve this just like that. We're going to display a message that tells the player that they were successful in their attempt. So here player dot name fled successfully. I think that's the original wording I used. Yeah. And then we can have the battle state, then enter a new state, which is going to be the fled state. And we're going to return. All right, so that's the logic for that. And let's check it out. Nothing should happen. I mean, the messages should be visible. So if I click on flee, Breeze attempted to flee. And then nothing is happening because we forgot to also have the logic where the fleeing is not successful. So to do that, when the fleeing is not successful, we need to actually have another message here. So await text box display line, and then $sign brackets player.name attempt. So the player's attempt failed. And then it's going to go to the enemy turn. So if we go and check that out, let's try to flee. And then what happens here? Breeze fled successfully. Okay, let's refresh. So we arrive at the case where it's not successful. Because remember, it's using a random... Okay, Breeze's attempt failed. All right, so we have this now in the fled state. So normally, if I look back at the result, I should be able to move, right? Ah, okay, because we haven't deactivated everything. So in here, in the fled state, let's deactivate the action menu so you can look at, like, have an understanding of how it works. So in the fled state, I'm going to deactivate. Actually, I might create a small function called deactivate UI. And this small little function, what it's going to do is simply call, and the way it's written this way as an arrow function is because remember in JavaScript, the arrow function inherits the, well, actually in this case, it doesn't matter, this here, but just for your information, when you use an arrow function, this is inherited from the parent context. While if you use the function keyword, this is its own thing, independent. So you won't have access to the same this that is outside here if you were to use this here. Just something you need to understand. So here, actually you don't need to understand this in this like right now, but in general. So in this deactivate function, I'm just going to call the text box and I'm going to deactivate it. No, not divide it, deactivate it. And I'm going to do the same for the action menu. And I'm going to deactivate it as well. And then here, I'm going to just call the deactivate UI function like that. And that's it for now. So now, if I go back, I have everything. Flee. Failed. Okay, we need to refresh because we haven't written all the other logic. Flee. Fled successfully. And then I can move back into the world. All right, so that's this part. In the next part, we're going to work on the items menu. Once this is done, we're going to be really ready to have a basic functioning battle system, at least in terms of logic. And then we're going to add the battlefield, the sprites. Once we have that, I think we're going to be ready to do all the little things when a battle finishes, etc. And then we're going to have an introduction to shaders, how to use them in Kaplay. More specifically, it's a specific like how to use it in Kaplay. And because there are some differences rather than if you use outside of Kaplay, the shaders. And then we're going to make some battle backgrounds, and that would be the end of the course. All right, so now has come the time to work on the items menu. So the items menu, like we did with the action menu, let's make a simple state machine. So now the difference between the action menu and the items menu is that we can have an unspecified amount of items in our items menu. So that means that a lot of these states, we don't know how many of them we have. So it's basically not finite. It's not a finite state machine, I guess. Anyway, let's do a diagram just to draw each of those. So like we did earlier on, a circle which will contain our first state. So our state here, like I said, we don't have a default, a specified default state. What I mean by that is that we don't have like attack, menu, item. Actually, we don't know them in advance, but we do have the disabled state. So we have disabled here, and we enter our state machine by going to that disabled state initially. Then we're going to activate that state later on. So as for the diagram though, it's much more complex in the sense that we need a way to have slots basically. So our items menu can contain a bunch of items, and the player can have a bunch of items, and each of those slots, each of those items that they can have is called a slot. And what we're going to do here is we're going to create, let's say, this state. First, we create a state called, let's say, slot 0 or slot 1. Let's start with slot 1. Then we have slot 2. And maybe I should zoom a bit. Slot 2. Then I'm just going to copy this over, slot 3, etc. So I'm just going to have slot 3. And then we're going to have a slot, a bunch of like maybe a dot 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 to signify a bunch more. And then we're just going to copy this again and paste it. So we have here slot, wait a minute, slot 4. Not 4, slot n, to specify that there's an n amount of an unspecified number that depends on how many items the player has. So that's our state. Now, how do we link all of this? Well, first of all, we have this arrow. So from the disabled state, we go to the first slot. Now, in the case that the player has no items, then we will simply prevent the items menu from being created in the first place. So that's why we can assume that it exists, that the slot number 1 actually exists. All right, now that we have that, the way we're going to move the logic is simply an arrow like that to move to the previous and to the next, and an arrow back to move to the previous, so on and so forth, like that. Here as well, and just to signify the same thing. And you're going to see in the code how we're going to implement that in a moment. So that's our state machine. That's it. That's it basically. We can only move from slot 1 to slot 2, and then from slot 2 we can move to slot 3, etc. And with an unspecified number of slots. So that's our diagram for the items menu. Whoops. The items menu. Whoops. The items menu. Actions menu. State machine. State machine. Like with the other diagrams, you're gonna find this one in the course material. Can I increase the font? Okay, here we go. That's it. Now let's immediately jump into the implementation. I think it's better for just jump right in. All right, so for the items menu, so go to the items menu file that we created previously, and again, let's import our k from our Kaplay context. So it should propose it to me here. All right. Now I'm gonna again export default a function, which is our constructor, make items menu, and it's going to take as a param the inventory, the current inventory. So I'm just gonna write inventory here. inventory. And now within, well, we can just, create our first a constant called slot states, and it's going to contain all of our slots, our states. So basically it's going to contain a string that will define the state for the state machine. So the various states we can have. Since we don't know in advance how many we have, we need to first store them in an array, and then from then on, we can, actually create the state machine by passing that array to the state component. So here I'm going to have a for loop. Let's start with I equal 1. And then I is inferior to the inventory.length. And then that's it, yeah. And then I++, the standard for loop. Here we start at 1 because the state starts with 1. So it's going to be slot dash 1, like we did in the diagram. So here in the diagram, we had slot dash 1, slot dash 2. So here, I'm going to have my slot states, and I'm going to push a template string, which is going to define the name of the state. How we're going to do this is simply type in slot and then dash and then $sign and I, the index, which is going to be a number from 1 to the number of items in the inventory. So now that we have this ready, we can start and create our game object, which is going to represent the menu. So I'm going to first create a constant to store it, because as with the others, we're going to add some child game objects later on. So here in the items menu, what I'm going to do is, of course, do the standard add function with an array. So here of components. Our components we're going to use is first the rectangle component with a width of 400 and a height of 300 and a radius of 4. Nothing new here. Then I'm going to set the color to being black for the box, and sorry if this appears here. I've increased the font size in this recording because I realized previously that the font size might be too small. Well, it's not that small, but maybe just to increase your comfort while following the tutorial, I thought I would just increase the font, even though it's very tedious to write the code in this fashion, because I have a bunch of menus that take too much space, etc., and I have to drag in a lot the scroll a lot to the left, to the right, sorry. But anyway, for your comfort, let's do it. So now I'm going to use the outline component and set the outline to being 5 of a thickness of 5. I'm going to use the color constructor to create our color 230 by 230 by 230 near white. Then the position is going to be 300 by 420. And this is what looked good in the UI. So you can experiment by placing various values you want, and you can see the difference. Now I'm going to also add the opacity component, opacity, and set it initially to 0, so the menu is invisible by default. And this is where we use the state component, where I'm going to first pass in the first state, disabled, and then in the array here we're going to do something, because we didn't add the disabled state to our slot states. So what we do is just we have an array, and we simply spread our slot state array within, so that all of the states within that array will be copied to this new array. And we add as the last element here the disabled state. Now, something about the spread operator is that it's not performant, but since we do this, since we still have a cap to the number of items we can allow, so this logic is made so that it can work with any number of items, but you're going to soon realize that if you actually allow an infinite amount of items, the menu is going to be too big in the UI. A way you could go about this is either A, to limit the UI, to limit the item in the inventory. Usually games do this, so they have a limited number of items in their inventory, and then you can expand that by doing some in-game content. Or B is you let it infinite, but you'll have to implement a scrolling feature. So as you go down, if the it get too big, so the menu never expands itself. It's just the items within the menu scroll down. So it's the previous items disappear from the top and the next item appear from the bottom. I haven't done this for this project because I thought that it wasn't really that necessary. All right, so now that we have our our state component set, let's add our custom properties. So I'm gonna have an items array, which I'm gonna use to store the items, the game objects for the items. So the game objects are usually just text that says what the item is. That's because in Kaplay, to create text, to display text, you need to create a game object and use the text component. Now I'm going to use the isActive here, boolean, to set whether or not the menu, the items menu is going to be active or not. Now, I don't remember if I actually use this later on. Probably I use it to make the menu disappear slowly. But because as opposed to the other menus, the items menu is recreated every time. So we destroy it and then recreate it. So just something to keep in mind. So this might not be useful. I'm gonna see in a moment. We're gonna see. I don't remember exactly. So just keep it for now, and then if you figure out that I never come back to this, then you know that it was not useful. All right, so I'm gonna set the current items index, the current item index, which sets on which item we are selecting, the player is selecting. So we start at 0, and then we're gonna update this depending on where the player is on the item menu. So let's create our first activate, few methods. So I'm just gonna first draw activate, deactivate here, deactivate method. Then we're gonna have another method called set controls. So this is basically standard like we had for the other menus, but of course the logic within is different, but not so different actually. I think you could have reused the activate, deactivate from the item action and item and other menus, because you just create either you create a function or something from outside and then you import it here. So your call how you want to organize this. So yeah, those are the only 3 methods we're gonna need in that game object. So in the activate, we are going to first set isActive here, isActive to being true. Then again here, oops, not active, isActive. Here again, I'm not sure yet. I don't remember if we actually need this, because for the action menu, we actually needed to check if it was active or not. But since we're destroying the items menu every time we create it, this might not be necessary. So just something to keep in mind. Okay, I'm going to use a tween, nothing special here. I'm going to set the opacity. This is annoying to write. The opacity. And then, so we take the current opacity, which is 0 initially, because we used here the opacity for 0. Then we want it to go to 1 in 0.2 seconds. And then I'm going to have the new opacity. Just this pop-up annoys me, you know. I might deactivate IntelliSense. So here we have our function, new opacity, which will change the existing opacity to the opacity here. Now here, when we're gonna have the child, so actually we can get those children from the children property here. We're gonna use that later on. We don't have any children right now. And then finally, remember the 4th param is the easing function. So k.easings, and then I pick the linear function. All right, now for deactivate, we're gonna use an we're gonna use an await here. So we need this to be async. The reason for that is when we deactivate, we first set that this is active to being false. We use our tween. And then after we have our tween, what happens is, let me just remove that. What happens is that we need to wait for the menu to completely disappear before we actually destroy it, as I said. So here again, await. So use the await keyword k.tween so that the code that will come after. So let's just write the code that come after is to use the destroy Kaplay function, which will destroy it. So k.destroy and then pass in this, which is the game object. Now here, same logic. So this time around, we take the current opacity, we set it to 0 in 0.2 seconds. Then we use the new opacity, so the function that will change the opacity. And then we do a k.easings, and then a linear easing function is what we're going to use. All right, we have our easing function, and now here this opacity will just be the new opacity. And then here again, to do for the children, I'm going to do this in an instant. And now for the controls, this is actually the most important part of the code base. And okay, why is it not working? Expected the comma. Okay, that's why. Here we go. You need to add your commas. So set controls is the important part because we need to adapt our logic so that it works with an arbitrary amount of slots. So here what I'm going to do is, I think we should first create our child game objects we need before setting the controls. So let's do that. I'm going to collapse this, and right below here, let's create our cursor. So I'm going to do items menu, and then have our cursor, and then items menu dot add. And then here, like we did, k.text, and then the right, the greater than symbol, which will act as our arrow. By the way, you can just, use a sprite if you want. Then the color is going to be 230 by 230 by 230. And the position is going to be 10 by 40. So this is the exact same logic as we did for the action menu. So feel free to create reusable components, reusable game objects that you just make. So that means there's what you can do is either you put those components into a reusable function so that you can just easily create the same cursor everywhere. Or you can use the make function where you do this. So k.make, which will create the game object, and then you put in your thing here, and then you pass the reference to that. So let's say you put this on, call it cursor from another file. And then what you're going to do is simply remove that and then type in the cursor, import it, and then just add it to the C. Now, one thing I'm not sure about this way of working is if the position is actually going to be relative to the parent or to the global screen, I guess, the global canvas. But it follows that since we're adding it to the items menu, it should convert at least to being coordinates relative to the parent. All right, so this is not what I'm going to do, but this is something you should do if you find yourself with a lot of UI, so that, and you see this pattern coming again and again and again. This is going to be the last time where we have to do this, I think, because we only have two menus, the action menu and the items menu we're currently working on, that will actually do this, need this arrow. So, yeah. Now below here, we're going to have an offset. We're going to set a variable called let offset y, which is going to determine a gap between each items in the menu. I think I should have called it gap y, like that, gap y, and that, instead of offset y. But it doesn't really matter, so I'm just going to keep it offset y. because I think we can both understand what is happening here. Here we're gonna use a for loop, and here we first gonna set our index to being 0 this time around, inventory, because this time around we need to actually pick from the inventory array, which is passed to the items menu. Because this is an array, the index starts at 0, you know, and this is not the same thing as our slots here, where we wanted the names to be slot-1, start with 1. So here the inventory.length, and then -1, and then as long as I is inferior to that. Well, by the way, you don't need the -1 here. As long as I is inferior to the inventory length, because remember, the greater the index can be is always inventory.length -1, since you know the length is the number of items while the index starts at 0. Something, yeah. And then plus here, I plus. Oops. Here we go. Now items menu here, we're gonna use that and then place a reference in our menu here. So push, we're gonna push into our items array, which is a custom property we created earlier on in the items definition, items menu definition here. This is where we're gonna put all the items game objects here. So the way we're gonna do this is we're gonna push, and then here we create the child game object. The reason I'm doing this instead of using .children, which is the default property that holds all the children of a game object, is that I want to only have the items here. Because when you have children that are not related to the items here, for example, the cursor is going to be a child. So I don't want that to be in my array. So something to keep in mind. That's why I prefer to just create a custom array for this items property and then push to it. So here we create our child game objects here, which are the inventory, just text. So I'm going to use the text component, pass in the inventory and then the index of that inventory, and then having the name. So if you remember when we defined the inventory, like the items of an inventory, so if I go back to maybe player.js, actually player's game state manager. Okay, our inventory is empty here. So maybe go to main.js for now. So main.js. We had our enemies and we gave them items, and the shape of the item of an item is usually a name and then a target, an effect, a value, etc. So this is where we're getting the name here. All right, and now let's add the color for that text, which is going to be near white, and then the position is going to be 50 by on the x-axis by the offset y for the y-axis, y coordinate. And then k.opacity is going to be 0 initially. Remember, we need to add the logic to make it visible and invisible. And then here we're going to pass a tag, which is going to be a template string that is going to determine on which slot the item belongs. And the way I do this is by doing the following. So now it's better formatted so I can explain more properly, I guess. So here, the reason we're using a tag like that is later on when you're going to need to select an item, we can know, okay, we're going to be in this state, for example. And since the index here starts from 0, then I have to do -1 to get the actual item. So there's something strange here is if the item is 0, then it's going to be slot -1. So that's something I actually don't think I used that in the end. So I'm going to remove that, by the way. Sometimes I write the code and it works and I had another design in mind, and then I continue working on the project and then forget that it's no longer relevant. And that's something that does happen to me. So it might become relevant later on, but at least we will know why. And then here, I think this is important. It's a custom property, which is the index in inventory. And this is important because we need to just pass this so that when we select the item, we can just pick that and remove or add, or yeah, remove the item from the inventory because it's going to be used. And then finally, at the end of that for loop, we can do it add the offset plus equal to, let's say, 40. The reason for why we're doing this is the gap. We want to add a gap between each of their element, or otherwise they're all going to be displayed on the same line, and this is not a menu. And then here for the expansion of our menu, so we want to actually expand our menu gradually. So after, let's say, 4 items, so I is superior, when we arrive at I is superior to 4, what we can do, a nice trick, is to simply take our items menu game object reference, and for the height property, you can just do plus equal, let's say 40, and it will add 40 of height to that items menu. That means that if you have a lot of items, it's going to expand and expand further. Starting from when we arrive at I superior to 4, that means more than 4 items are being displayed. All right, and then finally, you know, one thing we forgot is we need to actually return. So we do this, and then we return the items menu at the end of the day, at the end of the constructor. So there's still, of course, the functions that the set control method that I left out. So that's the time to work on that. So here for the set controls, our logic, of course, needs to, actually before that, sorry. We need to actually write the logic to make the menu visible or opaque. And as I explained earlier on, there is a bug in Kaplay where the child game object's opacity does not follow the parents. And that's really bad. So to fix this, we're going to have to manually change the code ourselves, the opacity ourselves. And here what you do is in the tween where we change the opacity, you do a for loop, and then here it doesn't really matter. I could use a short, I don't remember the name we give for this for loop. It's the for off loop, I think, where it's basically you create a constant off and then this dot items, and that's it. We don't need to think about it much more than that. And then opacity, and then we use the new opacity. Since we don't need to keep track of the index, we can just use that form of the for loop. And then we need to do the exact same thing everywhere else. So here below in the other tween where I left it to do, we can just paste that. And I think we also need to set the cursor though. Yes, and then for the cursor as well. So for the cursor, we have this, and then here, this dot cursor. Remember the reference we had here. We need to set its opacity. So this cursor dot opacity to be the new opacity. And then we do the same thing here below for right below here. All right, now we're ready to work on the set controls logic. So I'm gonna collapse that, and then let's write here. So as I said, we need to have logic that is going to adapt itself regardless of our the number of slots we have. But before doing that, let's first have our cursor, a small function that is going to place our cursor in the correct position. So let's just use a simple arrow function. And let's pass in the slot name here first. And then what we're going to do is we're going to take this slot name. Okay, I know why we needed this. So here in the tag, we actually need the slot, and then do this like that. So here we need an I. So it starts at, you know what? I'm thinking that maybe we can adapt this logic to work with 1 instead. So here, let's start at 1. Here in I inventory.length, let's, instead of I being inferior, let's say as soon as it becomes inferior or equal. So as long as it's inferior or equal, we can do this. And then here, we can just leave it alone here. However, the logic here, we're going to have to subtract 1 to have the proper index. Think that way. And then here, after, it doesn't really matter here. So since we at item number 4, it doesn't matter. It doesn't really matter. So we just can keep it this way as well. So now here in our slot for placing the cursor function, we're gonna get our slot item by doing const and then slot item, which is the game object, not the item from the inventory array. We use the get method, get function in Kaplay, pass in the tag name of the game object we want. That's why I added it. I added this as the tag of each of the items menu items. And then here I'm going to first, the second param is very important. We need to have recursive set to true. The reason we need this is because since the game object we want is a child game object, we need to set up the recursive property to being true. Otherwise, it won't be able to recursively look for the item, the game object. And then we take the first element. So this always returns an array, even if there's only one item. But we need the actual game object reference and not an array with the game object reference. That's why we take the element in the first slot of that array. And then simply what we do is we take our reference to our cursor, and then we can call the move to method, remember, and then pass in a vector 2 with the position, which is just going to be the same position in the the x-axis. So here cursor dot pause dot x. All right. And then it's for the y item, what am I saying? For the y coordinate, we use the coordinate of the slot item. So here pause dot y. Finally, we can set this as the current item index. This is important because it's the actual item that is being selected. And then we can get that from the game object by just looking at index in inventory, the index in inventory property we had here. So that now the selected item index is this. I probably should have called it selected, but it's not yet selected. It's just the cursor is on it. And then if the player will press enter in the battle system state machine, then it, while being in the item selection state, item action or items state, it's going to, pull this info and then use that to take it out from the inventory and deal the effect. All right, so now it's the actual logic for using that though. As I said, we need to write logic that is independent of how many states we have. To do something like that, we're just gonna have our for loop which starts at 1, and then as long as it's inferior or equal to the slot states dot length, we can continue the for loop. And then let's close the for loop. And whoops, it's not a comma, it's this. And then here, what we're gonna do is to first this on state enter. So we enter initially the default state. This on actually no, that's not at all. What I'm doing here is defining what happens on each of those states. So we go through all the states, and then for each of them we set up this event listener. So slot $$I, and then here we simply just call the place cursor function we just wrote here by passing in the slot name, which is again just the same template string with the index here. Now that this is done, we can continue on, and then if the slot states.length is equal to only 1, that means we only have one item, and we just return early. That means they can only use that item, so there's no point in writing the logic for the navigation of the menu navigation. So we place the cursor where we need it to be, so at slot 1, and then we just, return early, since we don't need to write the logic for the cursor to move up and down depending on the items. Now, if I is equal to 1, we do the following. So there's 3 types of cases. Either it's the first slot, that means we can not go above that with the cursor, we can not move upward, or it is the case where the I is equal to the slot state dot length, which is the last states. That means that's the last state. Sorry, that means we cannot go below it. So we're gonna have to write specific logic for those 2 cases, and then then it's the rest. So the rest is all that is in between. That means those states where you can move up and down. So just to clarify, so for slot 1, there is a specific logic where we will like to only allow the player to move down and not up. And there's the last slot n here, where we want the player to be only able to move up previously to the previous state without having the ability to go down. So hope that was clear. And now let's write the code for our first case. So here we're going to have an on state update. So when the slot number 1, it is, here it's hard coded because it's always going to be slot number 1 in that case. So what we do here is simply that if in is button pressed, then down, then we simply will be able to have to enter the state, this enter state, and then that state being the slot, and then the next state. Basically we can enter the next state. So I, the current state, plus 1, which is going to be slot 2 in that case when the down button is pressed. Now remember, be careful to not make an error. It's an on state update, not an on state enter. That means this runs every frame until we do this, and then it moves on to another state. All right. Now the other case. So that's it for this first case. We only do that, and then we actually need to continue. That means by using the continue keyword, we can skip over the other thing, and it's going to go to the next iteration of the for loop without running anything that comes after. All right, so now what I'm going to do is for the slot state.length, so the last state, we're going to have an on state update again, but for here, we cannot use a hard-coded string. We need to actually use a template string, and it's going to be slot I, so the current state. Well, you could technically just take this and paste it here, but it would be longer than just doing this. And then as the function for this that is going to run, it's going to be if k is a button pressed and then up. And then in that case, we can enter the previous state. So you do enter state, and then here type in the slot, and then I minus 1. So at the last state, you can only go back. And then finally, the logic, of course, I forgot one thing, is we need to continue after having set up that. And then, so that what comes next doesn't run if that was the case, if I was the last element, was this index for the last slot, sorry. And then for all the other cases, we have this on state update, and then we just pass in the slot template string, and then the function we're going to run here is going to be, let me just go down. So it's going to be an if first for is button pressed up. That means we need to go to the previous state when the player presses the up button, and so we're just going to enter into a slot, that is I minus 1. And in that case, yeah, that's it. And then we return. Here you don't have to return early. Yeah, we return early because we can, if it's not the case, if the other if, so if is button pressed is down instead, then we go to the next state by doing enter state, and then slot dollar, and then I plus 1 instead of minus 1 because it's the next, and it's not, it's down like this. I made a typo, sorry. And that's it, that's the logic. So let's check out this menu. So let's go back to our battle system. So we have our action menu control. We can set a constant, not a constant, a variable for this, because we're gonna destroy it every time, and we just want to keep using the items menu variable as the reference. So we're gonna replace the items menu in with another one and put it under the same variable. So here I'm gonna call make items menu, pass in the inventory. Do I have it accessible here, or do I have to? Yeah, I need to pick it up from the game state manager, so I'm just gonna do that. Game state manager, current, and then dot inventory. And that's it, we have our menu added. Now it's time to actually open it up, and the first time we actually open it up is when it's our turn. We pick our, we want to go to the item state. We are in the item state, and that means we're going to go to the items action, and then in the items action we activate the items menu. So let's do this, items menu dot activate. And then I think maybe I forgot to enable the controls. This is something I think I forgot to do. Items action, yeah, we activate. So if I go back to the items menu definition, I'm just curious. In the activate logic, did I activate? I didn't. Okay. So since we are initially in the disabled state, we probably need to quit that state and go to another state. So we need to, after the, or while the tween is going on, in the activate function, we can just do this, set controls to activate the controls, and then enter state, and then go to the slot number 1, which, as I said, if there is no slot number 1, we wouldn't even make the menu in the first place, because in our battle system.js we have this if statement that if the current state is items and the inventory length is 0, then we just display line no items left in inventory. So let's test that out. I think it should potentially work. And we probably need to have the logic to like for the items to actually do something, and this is going to be next. So let's look at the result. So now let's go in battle. Spider appears, and then if I go to the items, no items left in inventory. I forgot to hide items. So in the game state manager, let's add a few items, and the items I'm just going to copy and paste them because I don't want to type that out manually. So it's going to take too much time for me, and I might make mistakes, but you on your hand, you have access to the source code, but it's this. So you have a name, a target, etc. It's the exact same items. Actually not exactly, but there are a few different ones. So just so you can see the name, the apple item, boomerang, poison bottle, and then we have the antidote, revealing glass, leg hold trap, and the strong herb. Those are the items. So if I go back to the game, and then remember to save as you work on the project, because if you don't, you will not see any difference. So you need to hit Control S in your code editor. It's just something that is basic, but I just today saw someone that had an issue with that, so That's why it came to my mind to tell it to you. But anyway, people taking this course should be more advanced. So anyway, here we go. We have our menu. And now there's an issue. So we have apple, boomerang, poison ball, etc. Everything is cool. But I cannot move to the last item. And that's something that I didn't plan for. Why is that? I didn't have this issue in my original code base. All right, I figured it out. The issue is simply here. I forgot to add inferior or equal to the inventory length since we start at 1. That means we didn't create the actual final state. I think that's it. So now let's look at the result. If we have the spider appears and have our items, and then I can go to the last and move up and down. So here we go. We have our, maybe I should increase this, but anyway, there's no bug. So I'm just going to remove the console log. But anyway, we have a working action menu. So now we need, there's still some things left, not in the action menu, but like the behavior. So I think we're ready to tackle the item usage mechanic. So using items, their effect, etc. Now it's time to actually make the logic in the battle system for selecting an item. So here we have our items action on state update in the battle system. And what we're going to do here is fill this to do. So previously we finished with our items menu. Now we need to actually do the part where the item is selected and there is something that needs to happen. So let's get started. We're gonna first get our inventory. So const inventory, and then game state manager, and then oops, we get the current inventory, the current state, and then the current inventory. Then here we're gonna have some logic to allow the player to go back to the action menu. So let's assume, for example, you wanted to select an item and then you change your mind. And in that case, we need to be able to go back. So what I'm going to do is have this if statement that listens in the onState update. So every time the is button pressed, so the left button is being pressed, I'm going to deactivate the menu by calling the deactivate function. Then I'm going to remember the deactivate method for the items menu will simply destroy it at the end. So that's why we need to reassign to the variable a new menu. So we're going to make our item menu here. And then we're going to pass the inventory in it. So inventory, here we go. And then so we can activate it when we go back to the previous state, because you're gonna see in an instant what happens is we enter here for the action menu, we enter the state items, we enter back to the previous state, but for the action menu specifically go back to the enter state, to the item state. And then I'm gonna explain this in an instant. And then we are going to enable the controls of the action menu which were disabled, and then we in our battle state we're gonna go back to the previous state, which was the player turn, and then of course we need to return early in that case. And one thing we need to add here that is going to come in handy is that when you want to go to a state, the enter state allows you to specify a second param, which is going to be any params you want to pass to the next scene. And here I'm going to pass an object, and I'm going to create a property for that object called the cancel illness effect. Cancel illness effect. And I'm going to set it to true. That means that if we go back to the player turn state from here, we are not going to calculate some damage related to any illness the player has had, let's say status effects, because the way the battle system works is every time we go to the player turn, if they're poisoned, it's there that we do the damage calculation. All right, so we return early. And now here, just to explain how it works with diagrams, if I go back here what happens essentially is we are in here. So we are in the items action, and then the items menu is opened, and then we change our mind and we want to go back. So here it will go back to the previous state. So from from here it's going to go here. But for the action menu itself, which is still open when we go to the menus item, we're gonna specifically select the starting point as being the items menu. So it's a bit hard to explain like that theoretically, so maybe we should just look at the result. So the reason we press left, the left button when we do this, is so that like we go previously to the previous menu. So it's a bit hard to explain, so let's look at it in the game. So here, the text box appears, spider appears, I click on items, and then I change my mind. I do not want to use any item, so I'm gonna go back, and it's not working. It's not working, and we need to understand why. Let's continue on for now, and we'll cover this later on. So in the case we want to actually confirm and use an item, I'm gonna have another if statement called is button pressed, is a button pressed. And if the confirm button is pressed, that means we want to actually use an item. So I'm going to store the selected, not set interval, the selected item. So inventory dot, and then we're gonna remove from the inventory. So the way I'm gonna do this is I'm gonna first take the currently selected item from the items menu. The way you can achieve that, if you remember, is we had a specific property. So items menu current item index, which gives us the index. And then we can enter that into our splice function, which will remove the item at this index and only remove one item. And that's basically it. And then it returns an array, by the way. So splice, if I can get the autocomplete, does it tell you what it returns? Number, delete, count. Anyway, it returns an array. Returns an array containing the element that were deleted. The elements. There's only one, so we can just do this like that. Now that we have that, we can update the inventory by calling our state manager and setting the inventory to being the new inventory. Remember, since splice actually affects the inventory variable here, so this is modified so that we can just pass it here to have the updated value. Now, what I'm going to do is I'm going to deactivate the items menu. Deactivate. Then I'm going to create a new items menu here. So make items menu, because by deactivating, we're destroying and then passing in the inventory. And then I'm going to deactivate the action menu now, because we have selected an item. So our action was taken. Then I'm going to have an await message here that will tell the following. So text box display line. Oops, not like that. Maybe I should go here like that. It's going to tell the following. So $player name used, and then the $sign selected item, and then the name of that item. Since we have this accessible here, and then maybe a bank sign like that. So now that this is done, we can write our logic here for the various effects. So to do item effect logic. Now, before moving forward, I really want to fix this bug. The one where, you open up the menu, you go to the items, and then you cannot no longer go back for some reason. All right, so I fixed the issue that we had, and now I'm going to explain what happened. So the issue we had was that when I opened the menu, I can no longer go back like this if I change my mind. The reason is simple. It was these two lines of code. They shouldn't be here. Because what happens is that every time we go to the item, every on-state update of the item's action state, we either pressed the left key, or we pressed the confirm key, or we moved to the enemy turn anyway. So as soon as we were in this state, we were already in the enemy turn state, and this is why it didn't work. So to fix this, this is something we're gonna add, but at the end, after having used the item. So within the if statement. So here, just to go back to a bigger font, it's here. So that's the issue, and now we can actually start working on the items effect logic. So I'm just gonna remove a few print statements. So I added this to print out what happened, and I think I'm gonna reduce the font size a bit because it's too much. And now, yep. So we have this. I had another log here, and we're ready to work on the various effects that the state machine, the using an item will have. So let's go here in the effects.js, and let's create all of our functions that are going to act as the effect, basically, the various kinds of effect you can have. So let's first import k from the Kaplay context. Kaplay, whoops. Okay, it should do this automatically now. Here we go. I'm going to create a first function called reduce health, which is the basic reduce health function. And its goal is to, like the name implies, it's going to take the damage being dealt, and it's going to take a target as well as the second param, which is the enemy, or in our case, maybe the player, or if they receive damage. And then we do a if statement, and if the damage dealt is inferior to the target dot stats dot defend, not health, sorry, health, then we will do the calculation. So target stats, and then stats health, and then minus equal 1, not 1, but the damage being dealt, and then we return early. Otherwise, we just return a target. We just set the health stat to being 0 because the attack is overwhelming. The damage dealt is superior to the health of the target. So let's go back to the battle system. So I'm going to close a few things here and there. And now let's go to the battle system. And then here in the where I left it to do for the item effect logic, let's start writing our various effects. So when an item is being used, we need to check for a few things. So the first thing we need to check is the following. So if the type of the item. So here, let's have this if. So it's going to be a bunch of if statements, if, etc. So the first thing we're going to do is check if the item is of its effect, basically. So we're going to take the selected item that we picked from here, and then here we're going to do dot effect, which is a property that should be on your items. If you remember, if we go to the game state manager, this is how an item should look like. It has a name, a target, an effect, and a value. Optionally, it can have a bunch of other properties. Now, since we're not using TypeScript, we aren't enforcing any of that. So someone could, by mistake, put in empty object, and then everything wouldn't work. So that's a cool use case for using TypeScript, and just to have more safety here. Now, what you probably could do, make an if statement to check if the properties are there before handling anything or throwing an error, but you'll have to write a bunch of extra code for that. All right, so if the item is, okay, let's first have the harm effect. So if we have a harm effect item, we will simply call apply. Okay, you know what we wrote in the, so let me just have a to do here. Let's remove that for now. If I go back to effects, this is going to be a general function that we use when dealing the attack logic. But for our items, we're gonna have another specific function called function. It's going to be called, one thing I forgot also is we need to export. But for this, I think we're using it only internally. So that's why we need another function that we're actually going to use. So export async function apply attack effect, and this will take care of, you know, applying the attacked damage. We aren't interested in this for now, so I'm going to leave it to do. However, we are interested in the following function, which is also async. You're going to see why in an instant. So I'm going to apply, I'm going to call it apply item harm effect. And the values, the params that it's going to take are going to be 3. The text box, so we can display things as they happen, the target, and the item. And now inside of this function, we're going to have an if statement, and then if the target stats.defense. So remember, in our battle system, there is a whole defense and attack system. So each enemy and the player even has a certain amount of attack and defense. And it's a bit like the card games that you see, like Yu-Gi-Oh! And stuff like that, where each card has an attack and a defense. And then depending on the attack that is being done, we do a calculation, a difference between the attack and the defense to see how much life point damage the player will take. So here I'm going to have the item dot value. This is, of course, inside of the shape of an item. So it has a value, which is the amount of, either here in this specific case, the damage. So if the defense is inferior to the item value, then that means that we can deal some damage. So damage dealt, we're going to have this, damage dealt. And then we're going to take the attacker. Actually, you know what? It's not this. It's we take the item value, and we subtract to it the target defense. So target.stats defense. Now, once this is done, we can call this reduce health function to do the calculation for us. So reduce health, and then pass to it the damage dealt and the target. And it's going to take care of dealing the damage for us. And then finally, we're going to have an await here for the text box to display a line. So display a line, you remember, display a line, use wait 1 second. That's why I use await here, using the await k.wait. And that's why we need an await here. So here the text that it's going to be displaying is the following. So target.name received the damage dealt point of damage. And that's it. And then we simply can return. Now in the case where the defense is too strong, we're gonna display, we are not going to do any calculations. We're just going to display a message that the target name defense is too strong, attack deflected. And that's our first effect, I would say. So we can go back to the battle system, go to select item effect harm, and in this specific case, since we know that we are in the player action, it's going to be simple because we can just do apply item harm effect. And from there we can first of all pass in our text box. The target is always going to be the enemy, so we don't have to think much about it. And the item, we pass in the selected. Oh, I called it select item, but it's selected item. So here. And then here as well. Oops, selected. All right, so we have our first damage calculation. So the rest of the battle system works much the same way. And let's implement the heal effect. So what I'm going to do, instead of doing this one by one, let's go back to fx.js, write everything we need, and then we're going to just import them back. By the way, this was imported, so it should be imported at the top of your file. All right, let's go. So effects, the next function we're going to write, let's just do the apply attack effect, and let's get it done. So here again, it's the same logic, but instead we're comparing the stats of the player and the enemy. So target, stats, defense. So we check the defense of the target. And here we should have added the params here, the 3 params text box, target, and then, well, actually here we have an attacker, and then we have a target. And then we check if the defense of the target is inferior to the attack, to the attacker stats attack. So in that case, it's worth calculating and dealing damage. Otherwise, it's going to be useless. So here to go fast, I'm going to simply have this message afterwards when the defense is too strong. Then here, I can just write out the damage dealt constant, which is just going to have the attacker stat dot attack, and then we subtract this to the target stats defense. All right. Once this is done, we can call our reduce health function and then pass in the relevant logic. So relevant param, sorry. And finally, we display a message. So I'm just going to copy and paste that. I don't want to type it out. And that's it. So we have our apply attack effect. We're going to use that later on. So the next one is the async function, the apply item heal effect. Takes the text box, the target, and the item. Here the target is, of course, is going to be the one using the item. It would be weird if you had a player that use a health item and then it heals the enemy instead of him. So that would be really weird. And then here we're going to have a constant that is going to hold the resulting health. So I'm going to do target stats health. And then we're going to add to it the value of the item that heals. Now, of course, we need to check that the resulting health doesn't exceed the maximum health the player can have, and this was specified in the stats, the max health stat. So in the case it is indeed superior, what we're going to do is we're going to set the target stats health to being the max health. So target stats max health. And then we're going to again display a message called text box display line, and then the message is going to be target. You know what? I'm just going to copy and paste that to not waste your time. Here we go. So target name's health was already maxed out. Not necessarily already. I should just do was maxed out. because there is the case where the item will make your life points above the max health anyway, but you previously, before using that item, it wasn't, so that's why it just was maxed out is enough. And then we return early. Then what we can do is add a message here if the target start. Well, first we need the logic. In the case where the resulting health is inferior, we'll just set the resulting health. And then here we'll have a message. So it's kind of the reverse of the logic we had here, where we first have the case where the attack actually passed through, and the case where we don't is after the first if statement. Here it's the reverse. We if the health is already maxed out, we just do this. Otherwise, we will set the resulting health to being the health of the target. And then again a message here. I'm gonna go fast, so I'm just gonna print that, copy and paste it. So target name's health increased by item value. So we have that done. Now let's have a port async function, and this time around is apply item illness effect. So that's the recurring status ailment, which is in a lot of RPG games. We have first a text box, then we have a target, and then an item. And then here we're going to have a constant first that is going to determine if the illness is actually going to pass through. So here we're going to have an is_ill boolean, and it's going to use the random function in Kaplay, which will pick a number between 0 and 1. Actually, this is false. You can in Kaplay specify any value, any two value, which is the draw of using this function instead of using math@random. But for our case, we only need between 0 and 1. And then if it's inferior to the item, so the resulting value is inferior to the item rate of effectiveness, which is an optional param for when you have an illness type effect. Well, actually, it's mandatory. It should be mandatory. So, like I said, nothing is enforced. You have to do it basically yourself. You have to make sure to pass in when you use the harm effect. By the way, you could write a logic that if effect is this, make sure that these properties exist before doing the logic here. But for this project, I don't think it's necessary. But this is just a few things you could do if you want to have a safer code base. So here the rate, if it's inferior, if the value is inferior, that means we are going to make the target ill, and we have an if statement for that. So if is_ill is true, then we're gonna set the stats for that. So target stats illness, and then we set the type to being the item. I don't remember the property here. It's the type. Yeah, type of illness. So for example, if you want to have a burn effect, call it burn, poison, etc. They are essentially the same, but you could write logic in the future where you would have more complex options. For example, not only you would have a different recurring damage, but you could have a certain type of illnesses preventing you from playing your next turn, etc. And then here we want to set the recurring damage. So recurring damage. And the recurring damage is the item value in this case. And then that's it. Yeah, that's it. And then of course we need to display a message that an illness got through contact with the type of that illness. And then we return early. And then here, if the item did not have the intended effect, then we're gonna have a message that simply says that the item was ineffective. Now the next function is the export async again function apply item cure effect. So actually here it's not only actually we need another function maybe before that. We need not only to have the apply item illness effect, but we also can have another function. We need another function, not just can, is the async function, the apply illness damage effect. I think it's an effect in that case. I use this convention. So apply illness damage effect, and this whole function's role is to calculate the damage, the current recurring damage. So the logic for that is, again, it's going to be the same thing. So I'm just going to copy and paste and go over it. So here we go. So here we have a resulting health variable, which will calculate the resulting health after the recurring damage. In this case, we have target stat health minus the recurring damage. And then if the resulting health is inferior to 0 after that calculation, which could happen, a negative number, then we manually set the resulting health to being 0 because we don't want the health to go below 0. And when it's going to be equal to 0, then we'll have logic in the player state machine, sorry, not state machine, where if the life of the player or the target, the enemy, is 0, then we call off the battle. And then here we set the health stat to being the resulting health, and then we display a message that is hurt by whatever the type of illness it is. And then here, of course, I forgot to mention that we need the text box as a param. And we also need the target as a param. And then here we have two messages. So the first message tells the player that they are hurt or whatever the enemy is hurt. And then it tells by how much. And that's it. So here we just pass the recurring damage and then the name here. So the recurring damage is passed here. And that's it. Now for the apply item cure effect. So this again, text box, the target, and then the item itself. Then here again, to go fast, I'm just gonna copy and paste and go over everything. So here we go. Let me copy and paste that here. So what is happening? So first we have an if statement that checks if the illness type is of the same type that the item heals. So we do this by having a type property in that case. So as I said, here's an example. The antidote has a cure effect and a type of effect, like what type of illness it cures. So here, defined by the type property, poison. So in that case here, we first check that here actually it's the reverse. We check if it's not the case. In that case, we send a message that just says that the target name consumed the item, but it had no effect. And then we return early. Otherwise, we set the illness type to being null again. It was null initially. We set the recurring damage equal to 0, and that's how we have the character being healed. And then we say a message that the player, the target, sorry, was healed from that illness. All right, now let's have the apply buff item effect. Here again, I'm just going to copy and paste and then just go over it because it's the mostly really simple logic. So apply item buff effect again takes three param, the text box, the target, and the item, and then it computes the resulting stat value. So it takes the stats. So the target here is no, actually the item has a property called target stat. And if you look here, For the strong herb, for example, it has a target stat property that determines which stat to boost or to reduce if it's a debuff. But in this case, we're writing the function for the buff effect. And it takes that stat and then just add to it the item value. And then it modifies the stat to being this new resulting stat value. And then here we don't have a maximum stat level, like value, like with the health. So this is a design decision. You can decide otherwise if you want your game to have a capped max attack and defense for your characters at certain levels, for example. Here we have, so we set the resulting value, and then we display a message that the target specific stat here was increased by this value. And then finally we have the debuff. So here, export, apply item debuff effect, 3 params as usual. Same thing but with a negative. However, here we have an if statement, a ternary operator, which will check if the resulting value is superior or equal to 0. In that case, it will just set the value to being that. Otherwise, it's just going to set it to 0 because we don't want a stat value to be inferior to 0. It makes no sense to have -5 attack. That means that your attack never goes through, basically. That would be really bad. And then here we have a display line to say that basically the stat for that target was decreased by that value. And that's it. That's all the effects here. You can feel free to add any kind of effect you want. Expand this further to your own liking. So the next step is just to integrate all of this in the battle system. So now let's integrate those effects that we wrote previously inside of the battle system. So as we are going to see, we are first going to do this for the player, but for the enemy, it's going to be, again, we're going to have to do this again, but slightly differently. So instead of the enemy being the target, most of the time it's going to be the player. If we have a healing type item, so we're going to do this, and then here we go. So here I copied and pasted this. So if the selected item effect is equal to heal, that means we can call the apply item heal effect. I cannot import it. Okay, that's bad. So here, await. Remember, we await because it displays, it used the display, the text box, and we need to wait for the messages to fully display before doing anything else. So here, apply item heal effect, and then pass in the text box, pass in the target, which is the enemy in this case, and the selected item. Now here we need to actually do the same thing, having an await. And then the next one is the analyze. So this is a different item. So selected effect, selected item. Then the effect for that item, if it's a analyze item. So this is something, it's an edge case. It's a type of item that is only available to the player. That's why I wrote the logic for it here. What it is going to do is just reveal the stats of the enemy to the player in the text box. So in terms of like the logic you need to write for that, it's simply a bunch of messages that just go and pull, here are they. So here we wait 1 second, we display a message that tells you that that item revealed the enemy stats. Then we wait 1 second, and then we display the health stat of the enemy to the player visibly in the text box. Same thing for the attack state, and same thing for the defense state, defense stats, sorry. Attack stats and defense stats. And then I've put a delay of 0.2 between the two instead of 1, just to be faster, to just display all the stats more quickly. And then that's it. That's the logic for the analyze item. Now the other effects we have is the if the selected item effect is, I think the next one is debuff. So if we have a debuff, then we're just gonna do an await, apply item, apply item debuff effect, and then text box, target is the enemy, and the item is the selected item. And that's it. Now the next one is selected item effect buff. And in that case, we are simply going to buff our own. So here you need to be careful. You could make a mistake where you apply the item buff effect to the enemy. So the target is actually the player in this case. And then selected item as the item, of course, being used. So we have the buff, debuff, and we also need the illness and the cure here as well. And for the other functions that we use in effect.js, I think the attack, normal attack, I'm going to add them also. So here what I'm going to do is just if selected item effect triple equal, remember, be careful. And if it's the illness item, an item that causes an illness, we're gonna await apply item illness effect. We're gonna pass in the text box. The target is going to be the enemy, and the item is going to be the selected item. Now, next up is the cure, and here selected item again. If the effect is the cure, what we're gonna do is await and then apply item cure effect text box, and this is for the player. So that's why the player is passed as the target. And that's it. We can now comment this in again. So if we use any of those items, we use them, and then at the end we're gonna go wait 1 second and then go to the enemy turn. So that's basically it. Before we go and look at the result, what I recommend doing is to go to the attack action state and do the damage calculation here. And in this case, the only thing we need to do is simply remove the to do here and do an await and then apply the attack effect. And here pass in the text box, and the attacker is the player, the target is the enemy. And here we go. So let's look at the result. Actually, we might need to do some more groundwork, because yes, we can see like items. So let's use an apple, and there's an issue. Okay, what is it? Select item is not defined. Okay, this is an issue because I thought I renamed it to selected item. Okay, selected item. That's here the issue. So if I look at the result, do this again, and then pick an apple. Breeze used an apple. Spider's health was maxed out. Wait a minute. We passed in the heal the enemy. It's funny because I said to be careful, but I made the actual mistake. So here the healing is the player. We heal the player. So something that's funny. Anyway, let's do this, and then you can see that I can actually use the items. So Breeze used an apple, Breeze health increased by 2, and then nothing happens because we don't have the logic for the enemy yet. And the enemy logic is going to be slightly different because we're going to have to make the choices, have a policy, a way of the enemy is going to do the select which move to pick. And this is going to be in the next section. I recommend that for now we are going to actually work on the stats component here, the stat box. If we do this, we're gonna be able to see our stats being updated. So what I'm gonna do is here in our UI, we need the statbox.js file. Go there. So I'm going to import k from, I make always the same mistake. So here, okay, import k from, and then enter. And then we're going to export a default function called make statbox. And I'm going to pass, create a constant, create the game object here. It's the same logic, 350 by 500 is what looked good, with a radius of 4. By the way, if you could give feedback about the course and even on YouTube, do you prefer that I type out everything, or you are okay with me copy pasting sometimes? I can see both perspective, where some might prefer that I just type it out slow, like as I do right now, so that you have time to follow along without having to pause the video. Others prefer to just, copy and paste it, and they will just pause and type it manually themselves. So I would like to know. So color, here the color is 200 by 30, 200 by 30, 200 by 30. This is logic we have written a bunch of time, and I think it's time that you could maybe write a function that returns a few components and then you use it, reusable components. But otherwise, yeah, it's very specific values, so I don't think it's that necessary. So for example, this component is used, those two are used a lot. Maybe you could abstract that into an array or something, then you just call that. But I'm not gonna do that because I'm just saving 2 lines of code. If I were saving more, that would be better. For example, you would take those 3 and then pass in params, etc. Anyway, feel free, it's your call. Here we have our activate and deactivate, so I'm just gonna copy and paste it because this is the same thing over and over. So what I'm gonna do is do this and then paste it here. So we have the activate method, which here will make it visible, and actually not visible in this sense. Here the activate function, it brings the menu outside of the screen to the screen by pushing it on the y-axis. So it's going to go up. And that's another effect you can use instead of just having the menu appearing like from having a 0 opacity to 1. You can do this as well, like the text box. So that's why here we don't need the children, because to set up the children here in the function that modifies the value, because as I said, the opacity thing is a bug where the opacity of the child is not following suit with the opacity of the parent, but with positions, it's not the same thing. Position, they do follow along. Okay, so we have this, our stat box. Let's add some children to it. First, I need a reference to the player, so you can just do hold this in the constant and just do k.get, and then you get the player. So player like that, and the first item. The reason I'm doing this, let me just first check that in the player.js file is here, and we have the tag. Okay, we have it. The reason I'm doing this is because we're going to need to get the player name, etc., and display that on the top, and we need the name. So a quick way to do that is to just use the get Kaplay method or function. So I'm going to have our name card, which is going to be a child of the stat box, and is going to be a rectangle. So k.rect 350 by 60, which was the value that looked nice. The color is black. The outline is outline 5 with a new k color with a near white color. Then we have here for the name card, we're actually going to have a child for that as well, but we don't need to store the reference. So the child has a child. And in that case, we're gonna just have the text. So here the text is going to be the player name. So we pass this, we get access to the player name. And we're gonna have the anchor component center so that the text is centered. And the position that looked nice was to take the name card width and divide it by 2. And this is the position of the x-axis, so the center of the name card. And 30 is the y value that looked nice. Now for the stats, it's going to be different. We're not going to manually write the game object for each of them. We're just going to have that in a for loop. So we're going to have a previous pause y of 80. So it's the same pattern that we had for the items menu, where we need to create multiple entries dynamically. So here it's not yes, it's dynamic in this sense. We were taking the player stats and creating the various stat entries into the stat box like that, so that we, in the future, if we want to add new stats, we can do so. So here we have a for loop, const key in player stats. This is a different type of the for loop. It's when we want the keys of the stats object. And then if the key is either max health or the key, so if the key is either the illness key, we will skip over. So we just continue. We don't create an entry for these two stats because we don't want to display them visibly. So here, if you don't know where I'm taking this from, so if you look at the player stats, so in the state player stats manager, you can see it here. So these two stats, we don't want to display them. We want them to internally be, well, actually it could display the illness if you wanted. That could be helpful to have, but I didn't do it in my design choice. So I thought that it wasn't necessary to show that. You would know you were poisoned anyway, or when you heal. So here now what comes next is to create a game object which is going to hold the text. So stat text. It's going to be a stat box child. So we're going to add to it the text, the following text. So here, template string, $, and then we pass in the key, which is the name of the stat, 2 dots, and then we do player.stats, and then we pass in the key here to get the value. Then here, I'm just going to copy and paste that just to go a little slightly quicker. So like that. Now if I look at the result, so here the color near white for the text, and then here the position is going to be 15 on the x-axis, and then the previous position always is going to increase so that we draw them gradually. And then we are going to have a method called update on change, which is important. We want it to update as soon as it changes, and this we're just going to set an on update. Now this, you could have decided not to have a specific dedicated method to that. You could have decided to do this just outside the outside the game object definition, but you know, let's do it like that in case you want to do more complex things in the future. So I'm going to do key here and pass in the new, well, the actual value, player dot, or this, player dot stats, and then pass in the key here. So when the player stats update, this is going to update as well, but you need to call it. You need to call it here. So stat text update on change, and then call that function. And then after doing something like that, we also need to increase the offset. So let's increase it by 50, which is what looked good. So here, right below, I have this here. And then finally, we return, at the end of it all, the stat box. Stat the box. So stat text is a child of the stat box. Name card is also a child of the stat box, but it has a child of itself in itself, and it's the name of the player. Okay, so now let's display that box, and we're gonna do that in the battle system. So in the battle system, if I go up here, I think it was at the beginning for the, yeah, here, the display UI stuff. And we can just first define the stat box right below the text box. So here we go, stat box, and then let's make the stat box, and this will import it. And then in the battle start, we can activate stat box, not start box, stat box, activate. Here we go. And then of course, in the end, in the deactivate UI, we need to also, deactivate the stat box. Deactivate. All right, let's look at the result. I think we deactivated just like that. Could destroy it, but there's no point. I think there's no point to destroy it. Okay, let's look at the result. Now if I go here, and there's an issue. Like, I don't see my stats. Why is that? Did we set up the stats? Actually, we didn't set up the stats. That's why. So here, I'm going to go back to the stat manager. Well, actually, we did. But in the stats manager, we have our stats here. But I don't think we use them in the player stats. We don't get them. Okay. So what I'm going to do is I'm just going to call my game stats. Do we export player stats? Sorry. Player stats manager. Okay, it's not suggesting anything, so that probably means that we didn't. Okay, we do have an export d4 player stats manager. So if I go to the player.js, have here the player. Okay, here's the message. Now we have our player stat manager. We want the current, and we have all the stats, so we just want the current snapshot, the current state of the player stats. Now, if I look at the result, we have our stats. So now if I go to items, let's say I use a harmful item, or you know what, let's attack. Pre-attack, receive 2 points of damage. That was a bit stupid because I don't we haven't coded the enemy behavior for the player. No, for the enemy. Sorry. So here I'm going to use an item. Let's say I use a buff because we don't. It's uncapped, so we can see the values change in the stat box. So a strong herb. You see, my attack was increased by 2. If I go to my code base, you can see by default in the player stats manager we set the attack to being 5. So that's it. That's a big part of the code. What's left now is to write the enemy logic and then to display the sprites of the battle background, and then a few things here and there when it comes to losing, the flee action, etc. And then we're going to be able to tackle the shader stuff. All right, so now let's code up the enemy UI, not UI, AI. So to do so, let's go to the enemy turn, which is where all the action is going to take place for this. So in the enemy turn, we're going to have a bunch of effects to call. But let's first write our logic here. So we have a first if statement that checks for any illness the enemy might have. So we're going to do enemy stats illness, and then check for the type. So if this type is not null, this if is going to be resolved to true, and that means we can make the enemy apply the illness damage effect to the enemy, which will take the text box as the param, and then as for the target, it's going to be the enemy. And then we also need to check right after. So those if statements are going to run right after. We want them to run right after. So after taking damage due to poison, for example, we want to actually check if the enemy stats health is equal to 0. And not only in this case. So at any time we go back to the enemy turn, we check if the health is equal to 0. In that case, we can display a message telling that the battle is over. So display line that the enemy fainted. And then after that we can, say that the player won and then move to the victory state. So here the enemy fainted. We go to the victory state and it's there that we're gonna do the victory message. So battle state, enter the state victory. Victory. And we return. Now, we return early because if that's not the case, we continue. So the next part of the logic is to first have a variable called item was used and set it to false. The reason we have this is to basically know when an item was used after this turn, so that we can remove it from the enemy's inventory. And yeah, not necessarily remove it, but also know when an enemy used an item. That means they won't be able to reuse another item. You're gonna see in an instant how this comes up. So we have our item was used boolean to being false initially. Then we're gonna have a small little function, remove item from inventory. And this will simply do the following. It's going to go to the enemy items and remove the index. So the index, remove the item at the index. So we pass in the index of the item, and then we pass this to our splice function and remove one item, and it's going to take care of removing the item from the enemy's inventory. And then we set item was used to be true from there. And now is the meat of the AI for the enemy. So here we are gonna have an if statement that first checks that the enemy's inventory is superior to 0. That means there are at least a few items, at least one item. Because the way the battle system works is we have a enemy that is usually dumb. What it does is just attack, but depending on the items you give it, it's going to inform its strategy of which item to use in which situation. So the difficulty not only is the stats, the attack defense stats, but you can play with giving certain enemies certain items so that they act differently from each other, and this will add complexity to the battle system while not being complex to code. So that's as complex to code. So this is an idea I got, and I haven't seen it that much in well, actually there are probably a few games that have that system. So if enemies items.length is superior to 0, what we're going to do is we're going to check a for loop. We're going to do a for loop that will check the items, and this for loop is going to be something. It's a for loop that I don't see often. It's using an array here that has the index of the item and then the item itself. And the way you do this in JavaScript is const index item of object entries, and then you pass in the enemy.items array. Yeah, and then it gives you both the index and the item itself, because we're gonna need both. We're gonna need the index to know what to remove. Okay, so now that we have done that, we can have a first effect. So if our item effect is a cur, and the condition here, we want our player, whoops, this is not JavaScript. Here we go. So if the item effect is a cur, and we also want to make sure that the enemy stats .health is inferior to a certain amount. Actually, you know what? No, this is a cure because it's not a health, not a healing item. So what you do is at first, the order of those if statement also will inform the order of importance of a... Well, actually, yeah, the order of the items in the inventory is also the importance at which you want to give them to the enemy. So what I mean by that is that if you pick two enemies and you give them the same item but in different order, they're gonna act differently. They're gonna use certain items at first than others. But here we first check. So depending, like if you put a cur type, cur effect enemy item as the first element of the enemy's inventory, it's going to first run this. It's going to first check if the item is a cure effect and if the stats health of the enemy, not the health, the illness is of a type, illness is of the type cured by the item. By the way, just for things to look the same as we were the other, I'm going to have just this named selected item instead. So we have the same names used as with the player logic, just so things are less confusing. So selected item dot effect if it's a cure item, and the illness that the enemy has, if they have any, is the same as, not the value, the type. The type of of illness that the cure item cures. Then we can simply have a await apply item cure effect, and then pass in the text box, the target, which is the enemy, and the item, which is the selected item. And then we will break out of the loop, of the for loop. An item was used, and we need to actually remove item from inventory. So our little function we had above is going to be useful, sorry, not useless. And we can pass in the index here, which is going to remove the item from the enemy's inventory. Okay, in case we didn't have this item and we had the following, an effect item, a healing item, we're gonna use that healing item only if the enemy stats health is inferior to the enemy stats max health divided by 3, let's say. So only when the enemy's, maybe by 3 is too much, so it's only when the enemy's health is below half of its full capacity, full health, then we allow the enemy to use that item to heal. Otherwise it would be kind of wasteful. So here I'm going to display a line, and that line is going to simply be that you know what, I think in our apply harm effect, where is it? If we go here, we go back. Okay, here we need to have a message basically telling that we're using a specific item. So if I go back to the battle system, and then from the battle system, so here we have an apply item cure effect. And then here for the heal we need to display, because I think in the apply item cure effect we say that you consumed this item and either it had no effect or you healed from this disease. Because in the case where we make a message, let's say we display a message that says that you used that item, and then you'll have a redundant message that will say that you consumed it but it had no effect. So we could say, just instead of this message, we could have here, item name had no effect. And then here, if we go back to the battle system, so if I bring that file again, just to make sure I didn't do anything, I hit save. So here in the apply item cure, I'm going to have a message as well here that will say that we used that item. So for example, let's have it here. Oops, here we go. And let's have it here as well. So enemy used item, here we need to have selected item. Selected item, and of course here as well, selected item. And then here in the player code, I think we just had this at the beginning. Yep, so we don't need to add this again. But because we could potentially not use an item, we cannot have this only once for the logic here, where we only have one message here at the beginning that says, okay, we use an item. So what we could do actually in that case, we could, no, because we apply the effect immediately. So we couldn't use the fact that we know that we have the item was used variable to know when to display a message that says that this item was used, because the item would have been already used and the effect would have been already made before we are given the opportunity to show this message. All right. So here, and after the selected item, we can apply await, apply item heal effect, and then pass in the text box. The target is going to be the player. No, not the enemy, because it's the enemy that's healing. The item is going to be the selected item. And of course, don't forget to have the remove item from inventory and pass in the index. And then don't forget to break out of the for loop. We're going to see why in an instant after having done the effect for everything. So now, instead of doing this manually for each, I'm just going to have a copy and paste. Just copy and paste the next one. So the harm effect, remember to modify this to selected item, and then selected item, and then selected item. So here this should be imported. So what we do is we apply the harm effect, etc., and remove the item from the index, etc. And then for the illness, if we have an illness item which will cause an illness to an enemy, we have here the player being used here again. And then don't forget to have selected item instead. So here I'm just going to have that like that. And have this here as well. And that's it. Now for the other two ones, it's the buff and the debuff. We can also have this here, right below. And of course, don't forget to modify the if here. Selected item. And then here it's going to be a selected item for the buff, selected item for the name, and selected item here as well. And then finally the debuff. So we have the buff and now the debuff. And that's it. So select that. All right. So now that we have this, I'm going to collapse the for loop itself. And what comes next is actually outside of the for loop. It's even outside of the if. I'm going to have an if statement here. And if an item was not used, item was used is false. Then we're just going to do a default basic attack. So that applies doing the following. We have a display line, enemy name attacked, and we apply the attack effect to the player as the target. And that's it. In either case, after having either selected our item or just doing a basic attack, we return to the player turn. So now we should actually be able to see the results of that. So let's go. We have our battle. The spider appears. Let's attack the spider. And the spider received 2 points of damage. Spider used a poison bottle. Breeze got an illness through contact with poison, but I did not implement yet the illness effect for that for the player. So I'm just gonna use an apple. Okay, it was already maxed out. Spider used a strong herb, etc. You know what? To just, let's finish the logic for the player before testing. So for the player, if I go to player turn, in the onState enter, it's where we're gonna have two if statements, one for the same as the enemy, which after activating the action menu, we can check if there's an illness, and if not, if there is, we calculate the damage for that. And then here we need to actually use the await, so we can have the message here. So let's put this as a sync. One thing I want to say here regarding like flags, we have this, we pass something called flags here. This is an arbitrary name. You can put whatever you want, but what it is going to hold is any data passed by your previous scene. And if you remember in the items action, when we go back we want to close the menu before having used an item, just to go back to the action menu, we passed this object. So that would be the flag and the specific cancel illness effect. And the reason I'm doing this is that if I go back to the action menu, that means going back to the player turn state, which would run the illness damage effect if we didn't have this to differentiate the cases. So in the case that we are going back to player turn from the items menu, that means from a player who changed their mind, they decided that they no longer wanted to use an item, then when we go here, the damage is not going to be calculated for the illness. It's going to only be calculated when the player turn is entered from any other state. It's just something to keep in mind. And then finally, we have also the if statement that is here for whenever or not the player is defeated, which will go to the defeat state. I don't actually remember if we had defined the defeat. Okay, well, we have. All right. There's a few code to, there's some code to add in those two cases. So might as well do that also. So for the victory case, state, what we do is we need to display, so I'm going to just copy and talk about it. So do we have the deactivate UI method here? I'm just going to put this slightly above and remove this one. And what I'm going to do is just copy and paste the logic. I want it to here. We're going to have another. Yep. Here, I'm going to paste that and I'm going to explain everything. So here, let's first transform this into an async function. So first we say that the player won. Then we increase the experience by the experience of the enemy. This is just a way I decided to go with experience. Then we will display how many experience the player has earned. Then we will destroy the enemy game object in the overworld. Then we will call the deactivate UI function, which is here to remove all the components. And then we will set the is in battle to being false. And now there's the reset player stats. We need to also code. Let's do it right here. What the reset player stats. And what this function does is to simply put back the original attack and defense stat of the player, because we want those items that boost temporarily. We want them to temporarily boost the attack and defense, not permanently. So that's why I first get the current states from the player stats. So this player stat manager current is a read-only copy of the player stats, and it's going to no longer reflect the stats that we had here, which was local to the player game object. That's why we can use that to reset it to the previous value. So player stats attack and defense are going to be reset here. And that's it. We call that here. And that's it for the deactivate UI is going to contain another thing. So a bunch of other things, I think. We have this text box, the stat box, but we only have the battlefield yet. The battlefield is where we're going to add the bunch of shaders, etc. So I'm going to leave that for the end. And yep, so that's the logic for the victory state. Now for the defeat state, the logic is going to be mostly the same. The only difference is that we just display two message, and we only call we don't need to call the deactivate UI because we go to a game over scene, which anyway will destroy everything and go there. So we have a text box display line. So the player fainted, the player lost the battle, and then we reset the player stats anyway. And here, because actually resetting the player stats in this particular case, I don't think it's necessary, because by going to the game over state, you will lose any buffs you have, any stats, because we haven't written those stats value to the global state. So I don't think this is necessary. So let's comment it out for now. And then of course the is in battle state is false. We wait 1 second, we go to the game over screen. And then finally for the fled state, we have the deactivate UI thing. But we also need to reset the player states in case the player decides to flee the battle. So reset player stats is also going to be called here. All right, so let's look at the result. So I'll go here and we have our stats. So let's battle. I'm gonna first attack the spider. I received the spider received 2 points of damage. The poison bottle was ineffective. That's great. I'm going to myself use a poison bottle on the enemy. It's got an illness to contact with poison. It's hurt by poison. Its health is reduced by 2. It used an apple and its health increased by 2. Now I'm going to also use a leg hold trap, which will decrease the attack of the enemy by 2, and it's hurt by the poison. And it used an antidote and healed from the poison. Now I'm going to go to my items and reveal its stats, and you're gonna see I reveal the spider stats. Spider health is 2, spider attack is 3, defense is 3. So that means it uses strong herb, which increases its attack by 2, and I can just attack again, and it should feint the spider, and I won. I earned 10 points of experience, and I can. There's an error. Okay. Player stats manager is not defined at reset player stats. Okay, I probably did not import it, and that's why. So if I go here to the player stats, yeah, this is not imported. So I should probably do that here. Import player stats manager. All right, so you see that we have the battle system basically done. What is left now is just a few finishing touches and to start working on putting the sprites in the battlefield graphics and making the shaders, the backgrounds. So now let's do the few finishing touches for this project before we go and work on the battlefield and the shaders, etc. So now there were a few things left in the battle system, like making the enemy shake. We can do that only when we have the battlefield. And by battlefield, I mean just a square where we display the UI. And I think that's it. That's the only things left. So let's work on that. And yep. So first of all, I'm going to open up here, and let's work on, well, you know what, let's first test the battle system fully, and then we'll see. So there's the flee action we haven't implemented. Actually, I think we did. Let's try fleeing again. Failed. Okay, let's flee until we actually are able to flee. So here, okay, there's an error. Okay, this is not an error. I tried to flee, failed. Okay, you know what? I think we didn't implement the flee action, so that's something we need to do. So here in the battle system, let's collapse everything. So here, flee, attempted to flee. Okay, it's here. Okay, so we have the flee implemented. We have the enemy turn. You have the deactivate, the reset player stats. We have the victory. What happens in victory? What happens in defeat? And what happens on the fled state. Now let's add another enemy. That's one thing. That's another thing we need to do. So here back in main.js, I had a first enemy, which was the spider. Let's add a second one, which will be the make enemy. You know what? Yeah, make enemy. And here for the make enemy, we're gonna add the policeman, yeah, the dog policeman. So the values we need is, first of all, a position. Let's put the position at a vector 2, 600 by 300. Then we will have our name, which is the officer, so the policeman, the name of the sprite, officer, and then here we're gonna have the stats. I'm just gonna copy and paste them instead of typing them out manually. So we have here attack, defense, health, max health, illness, etc. And then the last param is the items, and let's give them the officer one item, which is the spear, which is going to target the enemy and inflict a 3, let's say 3. You know what, it should be more worth it, let's say 7 point of damage. Alright, so we have them both here. Let's look at the result. We should have, okay, so we have them both. So what I suggest is just creating the battlefield basic UI just to display the sprites, and then we will test the battle system fully, and then we can start working and adding shaders. I'm just like, I don't want to mess up anything. I think there's one thing left before that though. It was in main, we have our game over screen, which doesn't allow us to go back to the game after. So that's a good thing to fill in before we do all the rest. So here in the scene game over, what we're going to do is I'm going to have the player stat manager, and this should be imported, and I'm going to set the illness to being null and the recurring damage to being 0. This is a reset, because in many RPGs what happens is you're for example, you get poisoned during battle, but the poisoning still continues as long as you haven't consumed an antidote. I think that depending on the game, the poisoning only happens in the next battle, but it could be happening on the overworld. But for this project, let's just assume that the poisoning will happen during battle. So now by removing those status effects, we are able to get rid of that so that the players start fresh. So here for the game over screen, I'm gonna add a black background, so I can achieve this by using a direct component and having a width of the full canvas, screen size basically, the canvas size, and the height of the canvas size as well. And then I think we need to add a color, a color component. So let's just have it black. So this isn't very necessary, but you know, just to make things look nicer a bit. So 0, 0, 0. And now that we have done this, let's add some text, and the text will just be a game object with a text component, which will say game over, and we're going to have a size of 64, and an anchor of center so that it appears at the center, and the position is also going to be on the center by using the center function method, which gives us the coordinates of the center. All right, so now that we have done this, let's open up our file here, file explorer, and let's create our battlefield. Yeah, let's at least at the basic level. So we have an export default function, which is going to be our constructor. I'm going to call it make battlefield, and it's going to take a bunch of params. And for now, I would say the params are just going to be the enemy name, and the enemy sprite. And then there's an optional third param we're going to take for now. So I'm just going to leave it as optional, background shader, which is the shader we're going to use. And you're going to see that I'm going to introduce shaders very soon. And that would be like an introduction, a small introduction to what shaders are, how to use them in Kaplay. And then we are going to make our backgrounds, and then that would be the course. So here I'm going to set it to null as the default param for now. But afterwards, I'm going to require that there is a background, or we could leave it that way. I'm going to see. So I'm going to have a container constant, which is going to contain our game object, which is going to be a rectangle of the size of 1300 by 900 with a radius of 4. Then I'm going to add a color, which is going to be black. I'm going to have an outline of 5 with a new color, which is 200 by 30 by 230 by 230. This is a code that we've written many times. We're going to have an anchor. So we're going to position the container from the center. And for the initial position, it's going to be k.center.x plus 200 and then 1600. And now for the activate and deactivate function, same logic, but with just your specifics, and I'm going to paste that here. So we have a tween, which takes the y position and puts it the initial y position and then drags it gradually to be the center y position, so the position of the center coordinate, so y, the y on the y-axis, and then that's it, and then the reverse, and then we go back to 1600, which is outside of the screen. So it's going to slide in. Now that we have that, we can have the following. So I have the container. Now I can go to the container and add a child game object. And here is going to actually be the shader that we're going to add here. So for now, let's just have a to-do message. To-do add shader as child of container. Now let's add the other child, which is just the sprite of the enemy. So I'm going to have a sprite. I'm going to have an enemy sprite here as the name. So enemy sprite is the actual name of the sprite we're using. I'm going to also have an anchor so that it is drawn from the center. I'm going to scale the sprite 5 times because this is what looks good, otherwise it's too small. I'm going to set the position to being 0 minus 100, which is relative to the container. And finally, I'm going to assign a tag, and this is going to be useful when we're going to have the shake effect. So we're going to implement that next. So hopefully I don't forget. So this enemy name, and you just you give a custom tag that is specific to that that sprite, that enemy. And then finally we return the container. Okay, we have done this, and now let's use that in our main.js, not main, battle system.js. So in battle system, at the top where I say set up UI constructors, I think that's the last one, and then we're ready to remove that to-do message. So let me just place it. So let's do this here at the beginning. So I'm going to remove that finally. I have a const, call it battle field, and I'm going to add make battlefield and should import it. The enemy name is going to be enemy.name. The enemy sprite is going to be enemy.sprite, and that's it. So as you see, if we go to make enemy, which was one of the earlier files we wrote, actually enemy.js, we see that we have the name and then the sprite, and then here we have the properties, name, sprite. So that's how we are able to access the sprite name. So here in enemy name, enemy sprite, then we optionally have the shader, but not now. So let's keep it that way. And then here in the on battle start, we can activate the battlefield. So activate the battlefield. And that's it. That's the thing. So now it should be visible. We should also add the logic when to remove the battlefield. So remember, we had a specific function for that. It was called, where is it? It's right here. So deactivate UI. We are also going to deactivate the, let's do it first. let's deactivate the battlefield. So I'm going to call battlefield deactivate. Okay, now that this is done, let's take a look. We have our game and we have an issue. So what's the issue? K is not defined, and that's something it's embarrassing because I had this error many times. Here, don't forget to do import K from the Kaplay context, otherwise this will be undefined. Let's look at the result. And we have our enemy. That's cool. Now let's attack it. And yeah, okay, it seems to be working. Now what I'm going to do is I'm just going to refresh that. And okay, this is don't show again. It's not an error. Okay, now let's go to the other one. And we have our enemies as well. So what I'm going to do now is implement the shaking effect. So you see, each time the enemy has some damage, what I'm going to do is just shake it a bit. And here I'm going to write this logic in our enemy.js file, I think here. Actually, I'm not sure where I will put it. I might put it inside of the, yeah, let's put it here. Let's create a function, an async function, call it shake. And here we're going to have the, again, the same a logic that has come a lot in the past. It's this, it's tweening. We're also gonna add a drop down function. So when the enemy dies, we're gonna basically make the sprite drop down like in Pokemon. So here I'm just gonna go over the code here because it might not be very clear, the first line. So this is a shake function you need to create inside of the game object called the enemy game object here, right below the custom properties we had here. And so here first we get the sprite. So enemy in battlefield refers to the game object that refers to the game object that is displayed in the battlefield component. And remember this tag, we had this earlier on. If we go back to the battlefield file, so let me just go back to it, not here. So if you go back to the battlefield.js file, you can find it here. We set it up here. Okay, now next up is to go back to the enemy and finish this. So I'm going to finish explaining this. So here we use the get Kaplay method recursively because remember this sprite is, this game object is a child of the container which is in the battlefield. So that's why you need to have recursive true, and of course pick the first element because k.get always returns an array. Now the initial position that we're going to use is going to be the initial y position of the enemy in battlefield. We're going to use a tween, but this time around the await keywords are very important because we need to wait for the enemy to go down a bit. So the shaking effect is achieved by the following. We have the initial position. We increase 20 gradually in 0.2 seconds, which is pretty fast using a linear function. And then as it is down, because by doing plus 20, the value of y increases. And since the value of y increases, the game object goes down, the further down. Because remember, in Kaplay and in game dev libraries in general, the higher the value of y, the lower you get physically on the canvas. And now here, same thing, but in reverse. And since we have an await keyword, this will not run as long as this is not finished. And because this is also in 0.02 seconds, it's going to be very fast. So while we do this, let's add the other one, which is the drop down, which is in a tween that we're going to use, a function that we're going to use as soon as the enemy is dead. Again, same logic. We have the recursive true enemy in battlefield. This time around, we just make the character drop further down by doing this, plus 310. Those are values that looked good in 0.2 seconds. That's it. Now, when it comes to usage, let's go back to the battle system. So here, everything is fine. I can go back to the battle system, make enemy shake in the attack action. So let's do here. And let's take our enemy and just shake it. And have an await. So enemy.shake. This should work, hopefully. Let's try it out. So now every time I attack the enemy, you see, it moves. So if you didn't see that, let me increase. I attack. Here we go. And this will happen on every attack. And I think also we need to make this happen. Yeah, on every attack. You could go further and make this happen not only when attacked, but in all items that cause damage. So here you could add this when damage is... where should I add that? So heal, harm, maybe you could add one here. Await, enemy, dot shake. You add one here, and then that's it. That's the only other case. There's also the illness effect, but this you're gonna add that in the enemy turn. So if you go to the enemy turn, where is it? Here, when you enter the enemy turn, and there is a apply illness damage effect, you can add an await here with the enemy and then make the enemy shake. So let's test all those cases. So actually there's something I did that made no sense. Never mind, it makes sense. So let's try it out. If I go here, let's try poisoning the spider. Poison bottle. Spider got illness through contact with poison, is hurt by poison, reduced by 2, and you see. And then I'm also hurt by poison. Now let's use an item that does damage. I need to first use the leg hold trap to decrease the attack by 2. And I need to use the item, I think the boomerang. Ah, no, it's deflected. Okay, anyway, oh, there's an issue. We cannot use it here. We cannot use it here because if we use it here, it might occur that we try to use a harm effect, but the defense is too strong. So we actually need to go here inside of our effect.js file, and then in reduce, right below, maybe right after, or right below, right before. Do await enemy or target dot shake. Now there is an issue with that though. The issue is that the player does not have a shake method. So that's an issue. So maybe we could, yeah, that's a big issue. That's why I only added it to simple attacks. But I think we can figure this out together. So together, I mean, I'm alone thinking about it, but you can figure it out on your own as well. But what I would say is, if we look at the enemy, we have a name, we have a sprite, we have the enemy tag though. So is there a way to see if an enemy has a particular tag? There is no way to get the tag of a game object using stuff like that, like a tag thing. So what we could do instead is either set a property. So you could have a, like, you know, type enemy, and then using that we can just, if the type equal enemy, then we shake. So let's test it out. If we do this like that, oh, whoops, that's the final project. If we do this, then we have the item that could cause harm. Okay, maybe let's not do that with this enemy. Let's do it with the other enemy. And then if I do a boomerang, received, okay, use the spear, I received 5 points of damage. Okay, everything is working. All right, I think we're pretty much done. Let's try fleeing. And we can move. That's nice. And we have another enemy. All right, I think we're pretty much done. Oh, there's one thing left, is the drop down. So to drop down, we're going to, by drop down, I mean like when the enemy faints, we're gonna do this here. So in the battle system, in the enemy turn here, we are going to have the following. So if the enemy stealth is 0, it's going to faint. So what I'm gonna do is here, I'm gonna await and have an enemy dot drop down. I think that was the name of the method we created. Let me just check real quick. Yeah, drop down. Let's test it out. So we need to actually win a battle. So let's go here and let's fight. What I'm gonna do is first I'm gonna try to poison the enemy, and it was successful. Then I'm going to reduce. I also got poisoned, so I need to immediately use an antidote. And the player used an apple. I'm going to use a leg hold trap to reduce its attack power. And it healed from poison. And I'm going to use a strong herb to increase my attack. And I'll also use this. And then I attack. And you see the enemy failed. And let's go. That's a battle. All right, so that's cool. And we have basically finished the project, unless I forget something. And if it's the case, I'll probably just add another section or something like that with a few like remarks, etc. So now it's time for our shaders. The time has arrived to make our backgrounds. So the backgrounds, I think, is a big draw of this course. It's really like reminiscent of the game Earthbound, which used those crazy looking backgrounds to keep it visually interesting, and we're gonna do the same. Now what I want to do though is to explain how we're going to do this. And the backgrounds you see in here, for example, or the other one, if I refresh, if I go to the other one, those are the final backgrounds we're going to do, are made using shaders. So what are shaders? Shaders can be viewed as a way, as the printing, like the printing press. What I mean by that, in the past, we had scribes that would write out copies of books. So they would sit down, have one copy and their own copy which they were making, and it would take a lot of time, and they had to be really focused, and etc. Now when the printing press arrived, what happens was we were able to print books immediately, pages immediately, not sequentially. So not by writing line by line, we just had a frame with a bunch of letters, etc. And then you would basically engrave everything all at once. And that's the idea of shaders. They are done in parallel. So all pixels are going to be colored in a specific way immediately. And shaders allows us to do that, to take a texture or an image, which we call a UV quad. So a sprite is a UV, can also act as a UV quad. Or we take a empty like texture, which we call a UV quad, and I think it's called UV quad because it's a univariate quadrilateral. So univariate means, I think it goes from only 0 to 1 in terms of coordinates, and it's a quadrilateral because it's a square, a rectangle shaped surface. So quadrilateral. I don't know if that's the right term in English, but I know that it is in French. The term exists, and it means that it's a shape with 4 sides, and a square and a rectangle are both quadrilateral, but a rectangle is not a square. So basically that's the idea behind a shader. And also the idea is you have I would say 2 types of shaders. There are the fragment shader, which controls the color of each pixel, and there are vertex shaders, which are for like the position of each pixel. So here in this course, we're only going to use fragment shaders, which control the color of each pixel. So how does a shader look like? So here we have an example of a shader, and it's within Kaplay. So I'm gonna first try to increase the font, hopefully. Whoops, that's too much. That's way too much. Okay, let's go. Okay, that's really bad. So what I'm gonna do is I'm gonna take this and I'm gonna go into my code editor. And in the shaders folder we created originally in the public folder, I'm gonna create a new file. I'm just gonna call it test.glsl. GLSL stands for OpenGL Shader Language, I think. And it's a specific domain-specific programming language that is used to write shaders. And shaders look like, are drawn by this function. So a shader, a fragment shader, which is what we're going to do, can be defined by a function that looks like this. It has a few params, and it returns a color. So this function is going to run in parallel for every pixel in your image, in your UV quad, or basically the texture, the area you want to apply the shader to. Here we have a function, and this is specific to Kaplay in the sense that fragment shaders, depending on your environment, can be defined differently. But in Kaplay, this is how it works: is you have a GLSL file, which is a language, as I say, domain specific language. This language is specific to shaders, and it's universal. That means it regardless of the environment. It's not specific to Kaplay, but just the way we write our shaders using this signature function is something specific to Kaplay. So let's go through it. We have here a uniform. So what is a uniform? You can think of uniforms as params that you pass from outside of the shader. These are params that you can define here, and in Kaplay, in JavaScript, you can pass those values. So for uTime, you're going to pass a float, etc. You can see that this GLSL language has a specific type system that is closer to C, which mean that we have floats, we have vectors, etc. You have to specify the type, etc. So this is something important to keep in mind. Another thing that is important to keep in mind is the fact that everything here should be a float. When you write numbers, write them as float. That means that dot, 0, etc. The reason we need that is for the GPU. Now, depending on your GPU, because those functions are going to run in parallel all at the same time by the GPU, the graphics processing unit of your computer, which is different than the CPU. I'm not going to dive into the hardware aspect of it, but this is just something to know, and it doesn't hurt to do some research about that. Okay, so I'm going to recommend also a resource that to check when it comes to learning shaders. So just to go over it, here we have a color. So as I said, a shader is a function, a fragment shader more specifically, is a function that for each pixel will return a color, the color for that pixel. And the color for that pixel takes the shape of a vector 4. A vector 4 is basically like we had vector 2s, vector 3s, even in Kaplay, it's just 4 values. So for each channel, and then transparency. And here in shaders, something you have to keep in mind is that the coordinates, they vary from 0 to 1. That means the values that you have here, even in your color is not from 0 to 255 that you have usually when you're working with RGB. So enough looking at that. Let's implement. Let's do the practice. I think it's going to be a better use of our time. And once I'm going to write our first shader, I'm going to comment over what we're doing, why we're doing it, etc. And then in the end, you'll have access. I will try to put some links to resources you can look at to dive deeper in the topic. And there's also a website that is very cool called Shader Toy, where you can see what other shaders people have made, and you can even take inspiration and reference. By the way, this wait, where it is? This shader is taken from Shader Toy, and I just adapted the code for it to work in Kaplay. And yeah, so you're basically drawing with math. So by doing shaders, and you have to change your mind in a sense. It's not sequential. You cannot know the value of other pixels. Everything is run at the same time, so you need to keep that in mind when you're writing a shader or a fragment code here. So try to avoid if branching statements as much as possible. And there's a bunch of tips here. So you know what? Let's just write it out and then I'll show you. So our first shader is going to be the ring pattern. So the ring pattern is the pattern you see here, not this one, the one behind the spiders, which is a circle that is sideways and pixelated and then tiling itself. So I'm going to rename test.glsl to the following, to ring pattern.glsl. Now, something I need to cover is how do you import a shader code in Kaplay. The way you do this is the following. So as I remember initially, if we go to Kaplay context, which is where we put all of our statements regarding asset loading, I told you that there are two types of shaders. There are actually, I think, three, but the two types that are supported by Kaplay are the vertex shader and the fragment shader. We only care for this course regarding the fragment shader, and the way you're going to import them is going to be different. So here you do load. Let me just pull the reference. I think it's load frag. Yeah, load shader URL. That's the load shader URL. URL. This is the method in Kaplay. It takes a name you want to give to that shader. I'm going to give it the name of ring pattern. Ring pattern. It takes as the second param the path of a vertex shader, but in our case we don't care about vertex shaders. That's why I'm going to set it to null. And it's the third param that you need to specify the path where to find your shader, and the path for this is in the shaders / and then ring pattern dot frag. Actually, is it frag? Yeah, it's not GLSL, sorry. the language is called GLSL, but the file itself, depending on what you're writing, if it's a fragment shader, you do .frag. If it's a vertex shader, you do .vert. So something I forgot about. All right, so now I'm going to remove all of that and let's write our first shader. So here are a bunch of params we're going to bring from the outside. We're going to have a uniform. So uniforms are parameters that you can set from outside of the shader code. So in Kaplay, we're going to pass those to our shader, and they're going to be referenced as those names here. So we're going to have a float that is going to be the time. So the convention in GLSL is to use U for uniform underscore and then the name you want to give it. So that's a convention. It's not mandatory. There are people who don't follow this convention, but I thought I would just, follow it. Then we're going to have another uniform, and it's going to be a vector3, which is going to be the first color we want to use. So I'm going to have color 1. And we're going to have another uniform. By the way, here it's important to have this, the comma. Forgot the name of this. Anyway, it's important to have it. It's not like in JavaScript where you can leave it out. You will have errors. So we have another vector3, which is the color. I said that a fragment shader will return a color for each, and it's a vector4. The reason it's a vector4 is because there is the transparency as well. But for our uniform, we're just gonna pass 3 values, and then we'll deal with the transparency in the fragment shader code. So just something to keep in mind. So here uniform color 2, and we're going to have a float that is going to be the aspect ratio. So by the way, I explained that coordinates in a fragment shader are always between 0 and 1, and the reason I don't know necessarily the reason why it's between 0 and 1, but we need to keep that in mind. That means that if we want to apply a shader on a texture that is, let's say, a rectangle or something like that, we need to calculate whether or not we need to modify the aspect ratio of our shader code so that it fits here. It's not very important here though in our current project. And then we have another uniform, which is going to be a u.opacity for setting the opacity of our shader. And then we're going to define a constant. This is how we define a constant. It's going to be the pi constant, which is 3.1415926539. I think that's the correct. I don't remember by heart, so I'm just gonna copy and paste it here. Yeah, it was correct. And then we're gonna have a rotation matrix, which is in mat2 and then we're gonna call it rotation rot, and this is how it works. So yeah, shaders are math heavy. In case you don't want, this course will not dive deep into the math aspect of it, but in case you're not that good at math and you don't want to think about it too much, you can experiment. For example, look at other shaders on Shader Toy and see various effects and then combine them and then modify the value, and then by trial and error you can get effects, new effects, etc. So it's always better to know what you're doing, but sometimes we're just using the shader for a project. We're interested in the actual final result. So this is a rotation matrix, matrix, the matrix, which will rotate the circle, the shape we're going to draw in a moment. So there is a concept that how do you get actual shapes when you have to think about each pixel color. When you return a color, how do you get the shape? And you get a shape by using what is called a signed distant field or function. It's a function. Maybe I could have an example. So let me just look it up. Sign distance fields. Let's go. So Wikipedia. Okay, let's okay, no, this is too math notation. Here we go. So sign distance function are functions that return a single value, and if the point you have is within the shape, it's going to be inferior to 0. If it's alongside the corner, like the contour of that shape, it's going to be 0, and if it's above, it's going to be above 0. And that way you can color your pixels in such a way that they will naturally draw that shape. So maybe I had a resource for this, that you can have a bunch of common signed distance fields, and using that, it's going to be much handy to get the shape you want. I don't have it here, but you should find it in the course material. Hopefully I don't forget, and if I do, please remind me. So, okay, let's have our vector 4, which is the fragment shader. This is how you define a shader. It has a vector 2, which is the position. A vector 2 here, which is the UV. The UV is the coordinates of the image of the UV quad. The position is the position of the actual not pixels, but the shape itself, the surface, the UV quad. And we're basically not going to use that. We're just going to, what is really important is this. And the reason why we have this way of this function signature is specific to Kaplay. They have it this way. So they have another param called vector for color. We're not going to use that. Not 3, 4. And there is another one called sampler 2D, which we're not going to use as well. So there is a shader guide in the Kaplay documentation. So if I go here, kaplayjs.com, and you go to the explore the docs and maybe shader guide. Ah, the guide is here. So where's the shader guide? Can you start it? Shader. You can see it explains basically vertex shaders, fragment shaders, etc. It's just a simple intro. There's a bunch of things that aren't covered here, so I had to figure a lot of stuff out myself. Okay, okay, so we have our function signature here. Now let's start writing our function, our function. So what we're gonna do is I'm gonna reassign UV to being the UV plus a vector2. So UV is a vector2. It contains an X and Y value. And here I'm going to add to it UTime. So by doing vect UTime, so the time is something we're going to pass to Kaplay, the current time, since the shader was in the game, basically displayed. And by doing vector2 and passing in a float, that means a single value, that is a dot 0 or dot 0, which is something you need to do because of the way GPU works instead of using integers. If you do this, it's going to automatically create a second one. Even in Kaplay, it does this. So if you use a vector2 in Kaplay and just enter one value, it's going to assume that the second value of the vector2 is going to have the same thing. So we add this, and we multiply this by the I think I forgot a uniform here. Let's add also the speed at which we want our shapes to move, our circles. So here I'm going to have a uniform that is going to define this. Actually, it's going to be a vector2 because we need this. We need to define the direction. So we need both the X and Y coordinates. So we have a vector2, which is the speed. So we're going to multiply the resulting value by the speed. The reason I'm doing this is all arbitrary. I just want to make sure. I'm doing that because I want a specific effect. And this effect is to have our colors gradually move, and which will give us the illusion, but it's not an illusion, it's actually moving the pixels, even though the pixels are not moving. It's just the color that is changing. But by having a color that changes in each pixel, it can like simulate movement. Just something to keep in mind. And finally, we can multiply the result by a vector2, which is going to be I'm going to pass in the aspect ratio. So U aspect ratio. Now this, in this project, not necessary, but if you want the aspect ratio to be a certain, if you want to draw this on a rectangle, you want the shape to adapt to that aspect ratio so that the pattern will fit well, feel free to do it. So I'm just going to do it here just because I did it originally, but I don't think it's that necessary for our effect that we're trying to achieve in this project. Now for the rotation, I'm going to do this UV and then UV times the rotation matrix, which will rotate our shape. And all of this is changing colors only. But by changing the colors at certain places, you can have this movement. It's a bit hard to explain, but logically, like if I were to make a diagram, let's go back to Xcali draw. Imagine you have a square, which is, here is a pixel, here is a pixel, and here is a pixel. What happens, it's very simple. If this pixel is, let's say, this color, and this pixel is that color, and this pixel is that color again, what happens if you just change the color over time? Let's say you make the color of this pixel at the next frame green, and the previous frame, the previous pixel red. So it is going to give you the illusion that the third pixel has moved, but it's just the color that has changed. So it's not an illusion, by the way, it's just how things work, but just in case it wasn't clear. All right. So now we have a UV rotation, and don't forget the comma. Oops. So this will rotate. It's going to give a certain color, which corresponds to another color in the same, like another pixel's color, which is going to give this effect of rotation. And then we're going to have our first color that we defined from the outside. We need to have it as a vector 4, and we're going to have use color 1, which we passed, and divide by 255. Remember, by doing this, it's going to apply this division to all the members of all the elements of that vector, because u underscore color 1 is a color that it's a vector 3. So there's 3 elements, and this division is going to be applied. And remember, we're dividing by 255 because UV coordinates value from 0 to 1. And then we are going to set the fourth coordinate, the fourth element of the vector 4 as the opacity, which is just U opacity we had passed here. Now vector 4 again with our second color. By the way, I saw in many shader code they just call variables with 2-letter names. I think it's a bad convention, but I don't know if it actually matters in terms of GPU processing. Maybe the reason it's so small because, you know, there are some constraints, but I usually prefer to have variables that are clear and sometimes even long if needed. But it seems that this is not the case in the shader, like people who write shader code. So here I'm going to have a vector 4. I'm going to have a color, the second color. Again, do the same thing and pass in the opacity. So we could call it a day and just return one of these two and it will change the color. But to have our effect, we need to have our sign distant. Whoops, I made a mistake. It's opacity. And I made another mistake, which is I forgot to have the comma here. Not the comma, the semicolon. What? Semicolon, that's the name. I forgot. And then here for the UV, we're going to have a fractional. One thing I forgot is we want a pixelization effect. We're going to add that later on. But since we want tiling, the way you achieve tiling in shader is to use the fractional mathematical function. The reason it works is that it's able to repeat. The way it does it will remap values from 0 to 1. What I mean is if I multiply this by 10, is I'm basically replicating multiple times the same coordinates, and then fractional will remap this into a 0 to 1 coordinate space. That means that values now are going to vary from, instead of 0 to 1, it's going to vary from 0 to 10. And then by using the fractional function, it's going to remap the values from 0 to 1. But it's going to display multiple tiles. So in order to explain this properly, let's make a diagram. So initially, let's say you want to repeat the tiling 10 times, or let's say 3 times. So you have, you multiply your surface, I guess. Wait a minute. I'm not sure if I'm going to be able to draw something well. Okay, let's try it. So initially you have your UV coordinate, which go from 0 to 1. Okay, I need to go ahead like that. Okay, initially you have your UV coordinate from 0 to 1. And then also from 0 to 1 as well here. And let's say I want to tile this, the content of this. What I'm going to do, let's say I multiply my UV coordinates by 10. That means now my values are going to go from, let me draw, from 0 to 10 and to 10. So there's like 10 times the space to display, like the multiple version of that. And in order for us to have our tiling work, we need to go back to a 0.1 to 1 coordinate space, and using the fractional function, it's going to make sure that to remap the 0 to 10 coordinates to 0 to 1. So something, let's say you had 5 here, and here it's going to become maybe 0.5, I guess, 0.5 or some value. But anyway, I don't want to go deep into the math portion of this. At the end of the day, we're using shaders as like just for a pragmatic purpose to get our cool effects. Just remember the fractional function, the fractional mathematical function is what is needed to achieve tiling. And you multiply by a value. So here, that describes how many of the repeating tiles you want roughly, and then by calling it, it's going to remap it to our original coordinate space. Now, one thing I want to mention is if you want to learn more about shaders, you can go to the shader toy book, book of shaders. Not shader toy is another thing. So the book of shaders, a free book, I guess, which introduce shaders, how they work, etc. But remember, those concepts are not, you won't be able to apply them to Kaplay immediately. So the way I explained how to write shaders in Kaplay is very specific to Kaplay. So if we go to what is a shader, maybe let's go to turn off the lights. If we go to hello world example, you can see that, this is not the same shape at all. Yes, we are returning a vector 4, but it's set into a GL frag color variable. This is not the way we do it in Kaplay. But it's a good read, and then you'll be able to apply your knowledge and be able to make your shaders as well. So after having done that, we're going to have our signed distance field, which is, as I said, a function that returns a value. And if for a circle, this is the function. It takes the UV and have a 0.5 here. Actually, no, the sign distance function is going to be later on, but it's part of it here. So what it does here is for a circle, as you're gonna see, we're gonna the link. I'm gonna share a link that contains a bunch of sign distance function you can copy and paste and use, and those are mathematical shapes you can use like that, those functions. So it returns a float, and here the final step, and remember your semicolons, is to return a mix. So the mix, we're going to mix between those two colors, C1 and C2, following the distance function, the sign distance function, which defines a circle. So 1.0 minus the step, and then we pass in the L here, and then we multiply. So this is the function you need to use to get a ring. So this is very mathematical. I'm not gonna dive deep on that, but it's the way it is. And I'm gonna just show you another example right below, right after that one. So we have everything we need here, and yep. So now we're ready to test that out, to test if it works. We return the color. So now let's go to the battlefield, and here add shader as a child of a container. Let's do that. So the way you can display a shader, you can either apply it to a sprite, or you can create a UV quad, quadrilateral, univariate cannot pronounce it. But in Kaplay it's UV quad, and then you can specify a width. I'm gonna just take the container width and subtract 4, which is what looked good, and the container height -4 as well, which is what looked good for. And then I'm gonna set the anchor to being center, so it is drawn from the center. And I'm gonna specify the shader by using the shader component. It takes the name of the shader, which is the background shader.name, which is we're gonna pass soon enough. I'm gonna remove null here from now on. And the second param is going to be our uniforms, our params we want to pass to the shader. And here I'm going to call that background shader uniforms. And that's it. Now, of course, we need to go back to main.js and in our, for example, make enemy, add, I think, right, if I go here, yeah, let's go back to the enemy code. And in the enemy code, we had these params. We're going to change that. So instead of having pause, name, sprite, stats, items, we're going to have right after sprite, background shader. And we're going to add background shader to right below here as a property, custom property. And that's it. Now, if we go back to main.js, we can go here. So main.js, and then before our stats, we can add our shader uniform coordinates, I guess. So the way I'm going to go about this is going to be an object, and that object is going to contain the name of the shader we want to use. And the second property is going to be the params we want to pass in to that shader, which is called the uniforms. So if I go here, this is how it looks. So the name I want to use is the ring pattern, and the uniforms is actually a function you need to pass. So a function we need to pass to the shader component. So that's why I define this property as a function. And this function is going to contain all of our things we need. So here, I'm just going to copy and paste. So you define your, actually, I should probably just do this. You do this to return an object. And it will have the u time as the k.time divided by 10, which is what looked good. It can be any value, just play with it. The colors we want, here are the hexadecimal codes for them. And the direction is going to be 1, -2, and -2 in the y-axis. So it's going to move a bit slightly more on the y-axis. The u aspect ratio is just, I took basically the size of the container, the width and the height, and then divide it manually, and the opacity is 1. So you can play with those values as we want. And I think now it's time to go back to the battlefield and just to see the uniforms are going to be passed like that to the shader component. So now let's look at the result. So if I go back to here and I have an issue, so I'm going to open the console, main 28 argument list. Okay, what's the issue? What's the issue? Missing parentheses in main.js line 28. Okay, main.js line 28. Okay, I need to add a comma. So if I go here, let's go to our first character, and we have an issue. What's the issue? Cannot read properties of undefined. Make battlefield 39. Battle system line 38. Okay, why is there an error? Maybe I did not do it properly. So I go to battlefield. We have our container, our shader, the name, the uniforms. And this is our first enemy, the spider. Okay, so what's the issue? If I go back. Properties of undefined cannot reading name. Name. Okay, where are you trying to read that? Battlefield.js, line 39. Let's look at that. Battlefield.js 39, kshader, background shader.name. Okay, that's probably due to name here, ring pattern. That's the, okay, that's supposed to be the name. Okay, the issue I had is this. So make battlefield, you have enemy name and then enemy sprite, but we don't ever pass to the battlefield the shader. So here, if I go back to make battlefield, where is it? Battlefield.js. You can see that we have the background shader, but in our case, in the battle system, if I go up, we need to actually pass to make battlefield the enemy background shader. That's why. So now if we look at the result and go here, we have a non-pixelized version of our shaders. So how do you achieve pixelization? So to achieve pixelization, we need to go back to our fragment code and create, let's say we create a function, and that function is going to be called pixelize, and it's going to make sure to pixelize our shader surface by using the floor function. So the way you achieve that is, let's say we create a pixelize function. It's going to take a float, which is the pixel amount, how many pixels you want, and then the vector2, the second param, is going to be the UV coordinate itself. And then what we do is simply we return a vector2, and then we floor the UV coordinate, x coordinate of the UV, by multiply it by the pixel amount, and then after that, after flowing it, you floor it, you divide by the pixel amount. This is a mathematical property, and yep, so you do this with math though. And then the same thing for y, where you multiply by the pixel amount, and then you divide by the pixel amount, and doing so, you need to, of course, have the semicolon, and in that way, we have almost everything. So let's test it out. If we go back, refresh, recollide, and it's not pixelizing, and because we haven't called it, so we need to call it right before or after the rotation. We just do pixelize, and then pass in, let's say, 200 pixels. And remember, use always floats. That's why I use a float here, and then pass the current UV coordinates, and this should give us our pixelization effect. So if I refresh, recollide, and you can see it is pixelized. So that's our first shader. This is how you achieve it. And in the next part, I'm going to show you another one with triangles. And then after the one with triangles, we're going to work on the other shader, the officer shader, and that will be the end of the course. Okay, so now that we have our first shader, let's do our second one, which is going to be a triangle pattern. One thing that I forgot to explain previously was that the role of the step function. So the step function, it's a mathematical function that you give it a threshold, and if it's above that threshold, the value is going to be 1, otherwise it's going to be 0. So if I look at the book of shaders, the resource I recommended, book, or just type in step function shader, I'm gonna have here a definition. So generate a step function by comparing two values, and then for I of the return, if yeah, maybe this is, if it's above that value, it's 1, otherwise it's 0. So that thing, so here I think that's the line summarizing here. And now, so if the value is inferior to the edge, okay, but anyway, I think you got the point. So that's how we get a signed distance function to actually draw our shape the way we want. Because if you remember, a signed distance function, by the way, I want to show this resource. I'll provide the link where you have a bunch of signed distance function for the various shapes. So here, let's do another one with triangles, an equilateral triangle or a right triangle, and we'll try to make another shader, an optional alternative to the shader for our spider character. And then we'll work on the last one, which is more complex. So here I'm going to create a new file. I'm going to call it triangle pattern.frag. Pattern.frag. And then for the code, it's going to be mostly the same as our previous code. So just copy over the uniforms, then copy over the, here I'm gonna do it manually so that it doesn't come from nowhere. So here let's have our vector 4 that returns a fragment, the fragment definition. So it's not a vector 4 that returns a fragment, a vector 4 that returns a color, and we define the fragment function here with a vector 2 for the position, a vector 2 UV, which is what we care about, vector for color, and sampler 2D, sampler 2D for the texture. So sampler 2D, and then text as a texture. Yeah. All right. So what do we do first? We will make, like with previously, we can do the following. So we can either, you know what, I'm thinking that we could just copy and be done with it, you know. So we just copy our, like our ring pattern. We had this, we just copy that. Then we will have the rotation matrix. We need to pull that also from the ring pattern. So we make and pi as well. So these two lines, you copy that and you put them back here. Then here, of course, we're going to have the UV times the rotation matrix so that we rotate. We're going to pixelize. Again, I'm just going to take the pixelize function we wrote here and just paste it right above here. And now we're just going to do UV pixelize and then 200 as the number of pixels, and then we pass in the UV. And don't forget to, of course, have your semicolon. And then now what we're gonna do is let's add our, so in here in the ring pattern, we had our colors, and then here is going to be where we place our signed distance function. So I'm just gonna copy that again, paste it here. And now here for float L, you can call it D or whatever. It's going to be our signed distance function. So let's call it D, which is what, if you look at the resource, I think, okay, it doesn't matter really, but if you look at examples online, usually they store the signed distance function into a single letter variable called D or something like that. So now I'm going to remove that and let's write our signed distance function. Now, as I said, the signed distance function is something that I picked from here. So I just literally, you find the shape that you want to use and then you take it and you copy and paste it. So we're going to do just that. So here it takes a point, vector 2. Here we're just going to pass the UV coordinates to it. So now here we're just going to call SD equilateral triangle, which is the function I just pasted here. And then here I'm going to pass to it our UV, and then pass in a second value, which is a value param that you can play with. So let's pass to it 0.5. Remember, try to make your values vary between 1 and 0 and 1 maximum. And then finally, you know what? I should have called this L, or, let's call it D. We use the step function with a 0 threshold. And then, so by the way, the step function, you can determine the threshold here as the first param. So if I go back to the book of shaders, you have the edge, and then so edge specifies the location of the edge of the step function. X specifies the value used to generate the step function. So a step generates a step function by comparing to X to the edge, and then if it's above, so if for element I of the return value, 0, 0 is returned. So 0 is returned if the point is below the edge, and 1 is returned otherwise. So yep. So that's the threshold, 0.5. If it's above that, 1 is returned. If it's below that, 0 is returned. So yeah. All right. So now what we do is we have our step function, and then we can return our color, which is going to be return and a mix between the two colors we had, C1 and C2. We defined here. It's the same as with the ring pattern, so I'm just gonna call C1, C2, and then pass in the sign distance function applied to it, the step, of course. And then don't forget to add the semicolon. So the reason we applied here not two times, but the step, yeah, 2 times here is because to get a circle within a circle, like a donut shape. So depending on the shape you're using, it's going to be different. But for a triangle, it's just, you do this, you put it the step, your threshold, etc. All right, now let's look at the result. So if I look at so let's look at the result, and here in the ring pattern, actually, you know what? In the Kaplay context, we need to first import everything. So I'm just going to copy that again. I'm going to paste it and call it triangle pattern. Triangle pattern. Triangle pattern. All right, let's look at, well, first we need to use it in main.js also. So I'm just gonna call here triangle instead, triangle pattern, because it's the same uniforms we're using. Now if I go to here, and we have a pixelated triangle that looks like that. So that's another way. Now you can play with the values. So let's say I add, so this is mostly trial and error, and if you were really like have advanced mathematical knowledge, you could probably figure it out. So here, for example, maybe let's reduce by a vector 2. What we could do, for example, you know what? Maybe we could add a 0.5 offset like that. I wonder what this will do. I don't really know. Okay, why we have this? All right. So if I refresh, okay, there's an issue. It doesn't work. So here, when a shader doesn't work, you should get in the console an error, no matching overload function found. Okay, that's a problem of syntax. So this is here. We have a first closing. Okay, we need to remove that. That's why. So now if I refresh, do this, and then there's a syntax error. I forgot a semicolon probably, or okay, we need to have a bracket like that. A parenthesis, sorry. Now if I try, here we go. That looks much nicer. So play with the values, and then you'll see you're gonna make a lot of shapes, etc. Okay, now the last part of the course is to make the spiral pattern, spiral pattern. So just like this pattern, I took it from a website. I'm gonna put the link as well, but the website doesn't have it. Doesn't have the link. It doesn't have it formatted in a format that Kaplay can understand. So the original shader can be found here. And by the way, this is a good time to introduce shader toy. So if I do this, maybe here, I'm gonna paste it. You can see that's the original, and you have the code here. So I adapted this code to work in Kaplay and changed the color. So here there are a bunch of earthbound backgrounds you can find on shader toy. So let's click on that. You can see this one, that one, etc. So that are pretty nice. You can just pick them, modify them a bit, and use them in your game. So Shader Toy is the website where you can find examples of shaders you can use. So people share their creations here. So it's kind of an art in a sense. All right, let's go and write the shader. So for the spiral shader, the uniforms we're going to use are the following. So a aspect ratio, the time, the opacity, and the color we're going to pass, so we can make the color customizable. Now there is a first function, so we need to define, which is the spiral pattern. So to be honest, I don't know what happens here. It's something like, it's a bunch of mathematical functions that are used to give this spiral effect with the clamping, etc. I am not I do not know what this does exactly, but you can try just removing, changing the values, etc., and see the difference. There seems to be a difference in the way the waves are made, etc. So that's something. The pixelize function, we're gonna need it, and this is just here. We wrote it multiple times, so just copy it from the triangle or ring pattern. It's the same thing. And then finally we have the fragment. So I'm just gonna comment over everything. So we have this function. So this is the signature that Kaplay accepts. You can see that if I look at the example, if I go back and look at the code, you can see that this is not the same signature. That's why I had to adapt the code to fit in with the way Kaplay works. So we first multiply the x coordinate of the UV by the aspect ratio. So it's a bit equivalent to doing this, where you just multiply this part instead of having a second vector component. Because remember, with the shaders, well actually with his shaders, if you do something like that, if you were to do only one element, it would add this to the two elements of the vector. So that's why I added one here. But you could have decided to do, instead of that, to add another line and then have uv.x, the x element only, and multiply the u aspect. So it's another way of doing the same thing. Here we pixelize in the same way. Here there is an if statement. I said that it's usually preferable to avoid branching code in shaders. This is an advice I've heard. Now here it's used to get this waving effect in both directions. So here's the code for it. We use the modulo operator, and then if it's inferior, the result is inferior to 1. So yeah, we use the modulo operator on the y-axis with 2, and then depending on the result, we do something different by using the sine wave. So using sine function, cosine, tan, etc., you can get wavy effects, because by nature those mathematical function describes those like a wave pattern. So that's why it is used here. So if we go here, let me just show you the full line. So here, pause, and then pause here. You know what? I'm gonna just reduce the size of the font so that you can have everything in one line. You can have it here, you see. And then finally, there's a vector 3 called final color, which we take our color, we multiply. So remember, divided by 255. So we get a color that is has values between 0 and 1, because remember, UV coordinates are from 0 to 1 They cannot go until 255. And here is a bunch of we call the spiral function we created here initially, and then we use that and pass in a bunch of numbers, etc. And by passing the time, the current time, it's going to make it animate basically the wave. It's going to vary over time. So this is not a so one thing I forgot to mention is that if you go to main.js, if you go here in the when we pass the time, it's going to be like recurrent, so it's going to change gradually, etc. So that's something that allows us to get the animations. Otherwise, you would have still images, still results. So you would have the pattern, the triangle pattern, for example, but it would just remain frozen like that. So here also we multiply by the time, etc., to get a variation each second, while the game is running. So this gives the animation. Now here we have, it's a function that determines the final color we're gonna use, and then there's the short AMT. Not sure what this does though, but it modifies the final color. So if you go to the shader toy example, you can see short AMT, and it's called color shortening. It gives a kind of like a SNES-like palette. So I guess it's the fact that those color gradually become a different shade maybe, but this is something where it's out of my skill set, I guess. I don't understand specifically how it works. Remember that, like, the principal goal of this, the main goal of this course is to teach you how to make a battle system, an RPG battle system, and the shaders is just a nice thing on the side. So if you want to dive deep, there's probably a lot of other resources where they really dive deep into shaders. And now that you know how to use them in Kaplay, which is something that was not evident initially, you can apply your knowledge inside of a Kaplay game. So finally, we return our vector 4, which is the final color and the opacity we pass in, and that's it. So now let's import that shader inside of our game. So Kaplay CTX, and here load shader URL, and then we have the spiral pattern is going to be the name we're going to use. Remember to have null as the second param, and then because it's not a vector shader we want to use, and have shaders, and then you can use spiral pattern.frag, which is where the shader is located. And then finally, let's add this to our second enemy. So the way we're gonna do that is I'm just gonna copy this. I'm gonna collapse that, go here to the officer, and then I think it was after the stats, or before the stats here. I'm gonna paste that. Now here, it's going to be slightly different. So for the officer shader background, we're going to keep the opacity to 1. Use the same time here, but we don't really need to do this. So by the way, all these are arbitrary, like why you divide by 10, just like that, because it would move more slowly than if we were to just use the time. But for the the spiral pattern, by the way, change this. The spiral pattern, it doesn't, it looks better to move faster. So the aspect ratio, you know what, we don't care that much about that, just use 1. The opacity, what looked good was 0.6. We remove those 2 colors. Actually, keep one of them, but rename it just uColor, because there's only 1 color. And the color I picked for this is the following hexadecimal code. So just copy and paste it here. And then finally, we don't need to use speed as well. So let's look at the result. And yep, so we have spiral pattern and the params we need. So if we go and open up our game and go to the second enemy, we can see that we have our nice looking shader background. And that's the end of the course. There's only one thing left, is to actually teach you how to deploy that. Well, actually, you probably know how, but just to make sure that you're probably not gonna deploy this project like that. Probably gonna add your own stuff, etc. So anyway, you create a vite.config.js file. So you just do this. You import the defined config from vite, and then you specify your base folder as just being /. And then finally, you open up your terminal. And now I can close that, cancel, and then do npm run build. And then it's going to build your project, and it's going to create a dist folder. And then finally, you can do npm run preview to see if it actually works. So here I'm gonna copy the link. So let's do this. And it seems to be working. So by the way, you can just use the ring pattern if you want. In the end, it's the same thing. Yeah, you can swap between the backgrounds, etc. And that's basically it. One thing I would like to test though is, let's play our game a bit. Let's try to use some certain items. So let's say I used an apple and my health was maxed out, and I'm gonna on purpose just try to lose this battle. So I'm gonna try to use items that don't do damage. So for example, I could use the revealing glass to see the stats. Spider health. Okay. Now let's use it. Okay, let's just wait. Maybe I could try to use an antidote, but I'm not poisoned. Oh, I see an error. Okay, but I was poisoned actually. Okay, so I fainted. I lost in the battle, and it's game over. Now let's try to go back to the game. And there is an issue. I forgot to add the logic to go back to the game after you're dead basically. So I'm glad I did not call it a day. So let's go back to Kaplay context main.js, sorry. And then below in the game over scene, we can simply have a key on button press, and then we listen on the confirm key. And then if the confirm key is pressed, that means the space key in this case, we can just go to the playground scene. So now let's try this again. And the one thing I would like to test as well is that if I go here, so if okay, but I cannot do that. Whoops. The issue is I need to close this because we're on the preview and not the build. So you need to do npm run dev again. I have this, so I already have it opened up in my browser. Now we can test that out. So I'm just gonna try to lose to this spider enemy. So let's try to use an apple, which does nothing. I got an illness through poison. I'm going to use a revealing glass. Do nothing of value this turn. And then now that we have that, okay, used strong herb, and now I'm hurt by poison. I'm going to use a strong herb as well, which will increase my attack, but I'm not gonna really attack. So I'm hurt by the poison. I need to faint. So let's try to use a boomerang, which is too weak for the spider. And I get attacked, and then I fainted. Is hurt by poison. Was reduced by 2. Breeze fainted. Breeze lost the battle. Game over. And then now what I'm gonna test is that if I fight another guy, my items should not replenish. All right, it works. Now, one thing I want to test as well is if I refresh, if I increase my stats. So if I go here and use a strong herb, my attack is now 7. And if I try to flee the battle, my attempt failed. Okay, I need to actually flee. Okay, let's flee. Okay, it doesn't want to let me flee. And I need to flee. Okay, I fled successfully. Now my attack needs to be reset to 5. Okay, and I need to still take damage with poison. Okay, so it works. Okay, so the project works. Now one thing that we need to redo is to do the npm run build. npm run build to have the updated build since we had the bug earlier on. And then if I do npm preview, I will be able to preview my new game. So to deploy this, you need to either just, for example, on itch.io, you zip that dist folder and you put it on itch.io and should take care of itself, and it should work. And usually that's how you do it on platforms where you can host web games. All right, that's the end of the course. I hope this course was useful. I hope you enjoyed it. Don't forget to leave a review if possible so that others can know what to expect. And thanks for watching. Bye.